Hello, hello, hello. How is everyone doing, ladies, gentlemen? Oh, darn it. Man, I just can't catch a break here. Ah, jeez. As I was saying, thanks to everyone for joining us. I really appreciate it. Pardon me for the audio. I forgot that during the last stream we switched. I forgot that during the last stream we'd switched over to using the headset so that I could talk without causing any interference. So, yep, thanks for letting me know. Sorry for running a bit late today. We had a little bit of a puppy problem. My poor wife has been chasing Roscoe around the apartment all day, trying to get him back in the crate, and he just straight up refuses. We're only giving him food in the crate, so now he's stopped eating. Oh, that pup can't catch a break. He's a. Don't get me wrong. Roscoe is a delight when he feels like it, but he's a puppy. He needs a lot more play. He needs a lot more playtime than we're ready to give him. So, ladies, gentlemen, cyborgs, welcome to Voidstar Lab, where if we don't have enough problems, we make them. So, as is tradition, let's start today by logging into my shelves and turning on the lights. Got some really interesting stuff going on here in Voidstar Lab, and I don't even know where to begin. 100% lights, engage! Yeah, so I decided to name the printer. So first off, printer is done. It would help if I switched the camera on, wouldn't it? Before I engage the capture card. So check it out. Why is it zoomed in so close? This is our new E3D Toolchanger that I've called CoreXY. And I know the colors are really drab. I updated the camera. I updated my Blackmagic 4K the other night to get rid of an issue with memory cards, and it changed the color science. I've upgraded from Blackmagic color science 4 to 5, so none of my lookup tables that make it look nice work on this. The color is going to look a little drab, and I've been trying to get new lookup tables, but I'm supposed to be able to download updated ones, but the site's not letting me download them, and they're like $150 and whatever. It's a whole ball of wax. Anyways, today my audio is a bit high. We seem to be clipping out. There we go. That should do the job. So today we are going to be looking over the newly almost finished 3D printer. Maybe even making a couple little tweaks. And we'll see where it goes from there. You'll notice that a lot of the things in the to-do list have question marks next to them. In fact, I think even more should, because today depends a lot on what folks want to see. So we'll show everyone around. Show everyone around CoreXY. Explain the future of this project, and from there we'll decide where to go. We can make another couple of upgrades. We can try to set up a multi-material print, or we can just say, screw it, I'm sick of looking at this thing, let's move on to the next project. So, I appreciate hearing what you folks want to see. Before we get too deep into it, it looks like we had a super chat that I missed, and I don't know how to go back and filter it out. Lidlock TV, thank you so much for kicking us off with a very generous US dollar donation. I really appreciate it. Today's Mio is pure blue because I need to get out of that kitchen as quickly as possible before the dog started biting me. If you're in the Denver area, and if you're in the Denver area and you're like an active person, especially if you have other dogs and you're looking to adopt, Roscoe is available. Brooke, if you could put some info in the chat, that would be great. Yeah, Roscoe's a great dog, but there are lots of other dogs in that shelter in New Mexico that need rescuing from doggy death row. So it's time we open up a slot and get some puppers out of puppy jail and into some loving homes. So if you have one of those, Roscoe would love to have a new home. So yeah, let me show you around. Let me show you what's going on here, because is there ever a lot? All right, let's pop this in. Let's get this to stop wobbling. Let's switch over. Yeah. So this missed completely. Here we go. Let's get the mobile camera. That's right. So yeah, this is the new E3D Toolchanger. There it is. Check it out. Check it out. I'm gonna go back to this camera and just try to wave it around. This project has a big problem compared to some of my other ones, that it is big, and I don't build as many big projects. Anyways, yeah, check it out. This is the E3D Toolchanger. We've got the enclosure on the top and on the front. That's also the enclosure, those doors. We've got the liquid cooling system on the side. I hooked up some LED. I hooked up some LEDs on top, and I actually realized I should probably turn those on. This thing, the Duet, has a web interface, so I can just log into it, and run a script to turn on the lights. And it's actually a lot easier to do this than on my old printer, because it has 12-volt GPIO out. What are the odds, right? So, yeah, I built the enclosure showed up the other day. I built that up. It actually showed up shortly after we ended our stream. Yeah, we've got our four extruders from front to back. We have the Titan. Let's see, from front to back we have the Titan. Right, this is the water-cooled Titan Aqua. Actually, I should probably do this from the front, right? Yeah, so folks can actually see what I'm talking about. Yeah, let's show you the arsenal. Oh man, is this thing ever cool? I'm gonna be saying that a lot because it's really cool. Yeah, pardon the sketch camera work here. I really need to get a gimbal. And I need to get a gimbal and a new camera, because this thing in a gimbal would weigh around 10 pounds. A little more than I can easily carry around for an entire stream. Anyways, yeah, this is the Titan Aqua, which is a liquid-cooled, is it still in frame? Almost. This is a liquid-cooled extruder. The heat is being carried out to the side here, so the heat is being carried out to the side, so we can, when it's fully enclosed, it won't allow heat to creep back up. That has a copper, a copper block with a high-powered heater. This is a 65-watt heater cartridge, and it's using a PT100 thermistor to enable it to reach higher temperatures. Next to it, we've got a pair of just vanilla direct drive Hemeras, although you'll notice that they all have this super beefy part cooling fan on this side. This thing is ridiculously powerful. It sounds like a leaf blower, and it makes the thing almost too heavy to stay on the rack, but it cools off the part like nobody's business. This thing is rad. And those just have your standard E3D block. It's the same as the Prusa, and just your standard brass nozzles. Those two are going to be used for multi-material printing. And then next to it, we've got a third copy of the same thing, a third copy of the same extruder, except instead of having the standard E3D block, it has the Volcano. See that? You might not, but trust me, it's there. Yeah, it has a Volcano, and yeah, it's got a Volcano heater block. That's sort of a longer, sort of like a longer heater that is better at heating up large amounts of filament quickly. And that is loaded with an E3D Nozzle X. It's a high temperature. Yeah, that and the Titan both have the E3D Nozzle X. It's like a high temperature abrasion-proof nozzle, and that one also has a PT100. So the two outer ones are high temperature extruders, and the two inner ones are standard extruders. And yeah, it gives us a lot of control over what combination of stuff we can print. They're actually high temperature support filaments, and there's some interesting things you can do, like printing the outer part of like a high strength model out of a material like PEEK that is that's very abrasion resistant and tough, and you print the inside out of something like carbon fiber PEEK, which is much more rigid. So yeah, basically, if something can be printed using FDM technology, odds are we can run it off on this machine. Full stop. On top of all of that, the Titan, I don't have it configured for this yet, but the Titan can actually accept, and possibly the Hemera, I'm not 100% sure on that, but definitely the Titan can accept 3mm filament. So I'm not sure if we're going to use this because it does require a different nozzle, but yeah, we should be able to run virtually every kind of filament through this machine. And yeah, let me show you the back, because for the first time in my life, I'm actually proud of my cable management. Let's see if we can do this without ruining everything. Look at that gorgeous cable management. Just look at it. Oh, there's too much glare. You can't look at it. Oh, look at that gorgeous cable management. It came together so nicely. Oh man. Yeah, these blue things right here are custom parts. Basically, there are holes cut in the back, in this back panel for the for Bowden extruders. Since we're not using a Bowden, I decided to instead build these little blanks here that help us organize our wires. Yeah, we've got over there we got the Duet, that's the rep driver board, and the Duex, the expansion board. On top of that, I don't think it might be hard to see it, but let me see if I can zoom in and capture it. All right, this right here, might not be able to see it, but that right there is a special amplifier board that lets us run those PT100 thermistors. Without that, we wouldn't be able to do so. Our sensitivity is turned up way too high. Yeah, so you notice we've got the back panel on, protect us from, you know, all the voltage and stuff. We will be taking that off later, depending. And yeah, over here, oh, a giant spider just scuttled out of view. It was, it's one thing I'm still getting used to here, is that here in Colorado, the spiders are mean. Over in New York, the spiders are friendly. You get spider bros, but over here they're mean. So I gotta switch from save mode to stomp mode. So, yeah, we've got our liquid cooling system here, this bracket, and this bit here. Oh, you can't even see that part. This bracket that holds the radiator is custom. Yeah, we've got some DC-DC regulators up here. Yeah, we've got this little bracket that lets that gives the tube some strain relief and passes them through the side. That's also a custom design. You'll notice that I had to carve a pretty gnarly hole using a Dremel out of the side of the acrylic so I could pass the tubes through it. In retrospect, I really should have designed the liquid cooling part first, and then modified the enclosure in Illustrator. But yeah, that's it. That's the system. I decided to name it SquirtSephany. Oh no! Hang on a second. The original name was going to be Squirtburris because it's got multiple heads. But I decided on SquirtSephany because she's in Hades. It's guarded by the dog, and plus it's funnier. I didn't want to think of dogs. Let me try to frame this up so we can get our patron matrix in view. It's been too long since I had this up, and we are really grateful for our patrons because this project, E3D did contribute the printer and some of the accessories, but the budget for this project has ended up going completely out of control. Between that and all the filaments for the Every Film episode, this project has been quite the undertaking. So thanks to everyone who donates. I'm going to be paying closer attention to our Patreon activity. So if folks become patrons during the stream, I'm going to try to do a lot better to shout you out. We actually have had a couple recently, and for that I'm very grateful. So that's the grand tour. If there are any features that anyone would like to see a little more in depth, I certainly can show them off. But I'm thinking we should do a little print. And to make that possible, today's stream is sponsored by none other than, you guessed it, it's right there in the corner. There's no point building any hype because it's right there. Things.com. Things.com is your source for any kind of 3D printable or even just modeling things. Oh, hey, it looks like someone took the collapsing katana and rehosted it for me. Very nice. So Things.com is your place for any sort of 3D printable, modelable, just anything that has more than one dimension, or anything that's more than one dimension. You can actually put DXF files on this now. Things.com has been super generous in sponsoring the stream. They've made it possible for me to do all kinds of 3D printing related episodes, and they've been very helpful for this one too. So thanks a lot to Things.com. Let's find something nice that we can run off quickly. This printer is what's called a CoreXY printer, and that basically it's a different type of construction. And there are a few differences between a CoreXY and a Prusa. I might actually. So one of the other things that should be on this to-do list is one of my Prusas has one of the Y bearings has died. So we've got some IGUS bearings. So we'd like to repair that. A CoreXY printer can print much faster. It has a much higher top speed. Oh, this is cool. We got a Judge Dredd. We got a Judge Dredd badge. It's pretty sick. Yep. One of the cool things about Things is that you can quickly preview the part. This could look pretty sick. Let's. I'm going to keep that one in the back pocket while we look around for something else. I'd like to. So let's see. I missed a... Oh, right. JMan095 says, do a functional print. I'm looking for something good. I'm looking for something good. I want something that we can print quickly, because, we want to be doing other things besides running off a single print. What I'd like to try is running off a multi-material print, but I'm not very... let's just say I'm not very optimistic about my ability to do that. I've never run off a multi-material print at all under any circumstances, like on this printer or on any printer. So I don't really even know where to start, and I know that every time I stumble or slow down for even a second, I lose all my viewers. So Luca Van Spanu says 10-minute benchy. Bob Weir says print a keycap. That could be interesting. Let's see what kind of options we get. This thing should be able to do some pretty detailed prints. So let's see. This is so as you can see, Things searches itself as well as all kinds of other sites like Thingiverse. Oh, you do a sus key. Oh, what do you think? What do you think? Oh, let's do a sus key. Oh, that's sus. Yeah, let's download this. No, Benchy can't do a Benchy. I mean, maybe we'll do a Benchy later, but Benchy takes in the neighborhood of 2 hours to print, and at 0.2 millimeter Z resolution. It's actually not. I mean, it's not a very fast print. It's not designed to be, right? It is a torture test after all. So yeah, let's print. Oh, I should probably put this over here. So yeah, let's print an Amogus keycap. This thing is sus. This is not the slicer. This is just Windows Preview. Yep, there it is. All right, let's do that. That's a perfect print that's a perfect print for this. So we're going to be using Super Slicer, which is the open source fork of Prusa Slicer. It's sort of like the Chromium of Prusa Slicer. And I've got this pre-configured with a modified version of a Toolchanger profile provided for me by Rene, who has been very helpful. He actually dialed in last episode. We're not planning on having any guests today, but we might in the future. That went very well. Yeah, so I've already got some profiles set up. One of the big problems is that by default it will wipe the. All right, so here, check this out. I'm gonna. One of the neat things about this is that since this is multi-extruder, when you dock an extruder while it's still going, it's going to ooze, right? Because when you park a printer, it oozes. I really wish I had a fixed focus lens. Oh my god! Can I set this to? I set this to auto exposure. Why is that so dark? Ah, there. What the hell's going on here? I don't think auto exposure is working. I don't think that's working at all. Anyways, it's got this little brush here. Oh crap! It's the spider. Hang on one sec. All right. Yeah. So it's got this little brushy brush here, and the purpose of that is, well, so the filament's going to ooze out of the end when the tool is docked. You can't cool it down all the way, or it'll take forever to print. So it runs over this little brush to wipe off the booger that falls out of the bottom of the printer, the bottom of the nozzle. And I haven't calibrated that yet, and if it's a one material print, it doesn't need to wipe. So yeah, I've modified that to remove the wipe. So yeah, let's switch back over here and yeah, check this out. All right, so we've got this little keycap here. We definitely want to have a brim. We're going to want some supports, I think, because it's hollow in the bottom. Yeah, we're definitely going to want some supports. Let's change the. So you'll notice that this. You might not notice because everything's too. You might not notice because this text is unreadably small. While I change that, note that there are far more options. There are far more options in Super Slicer than there are in Prusa Slicer. I don't actually know why this is, because I was under the impression they had the same. I was under the impression that they had the same. Oh wait! Oh no! Oh, I changed the I changed the display density on the wrong monitor. That didn't help me at all. Let's hope nothing crashes. I was under the impression they had the same features, but that is certainly not. That's certainly not true. Why is the display? Why is every setting in like 3 places on Windows? There we go. Ah, perfect. Perfectamundo. Very nice. All right, let's get back to Super Slicer. Super Slicer! Look at all these options. There's so many options. It's ridiculous. There's so many options. Oh hey, I missed a pair of I missed one super chat. Yeah, Akelia Elementia, thank you so much for your support as a patron and as a super chatter. Can we get a round of Fs in chat for the spider? no mercy for mean spiders. Oh. Yes. A lot of folks are asking about my about what I'm using to organize all the windows. That is Power Toys. That's Power Toys for Windows. And if you don't have Power Toys and you're watching this, like, you absolutely, it's free. It's made by Windows. It's a first-party app. Yeah, you should download it. It lets you set up like all kinds of ways to snap windows. It lets you create a launcher, so you can search for stuff. And it's got a bunch of other odds and ends. It also has this neat thing where you can right click on an image. If I can find an image, there has to be at least one image here, and you can like rotate it or resize it right there from the menu. It's very useful. Yeah, that's Power Toys for Windows. Anyways, I'm going to modify this. So, all right, we don't need 3 parameters. It's too many. I do want to slice this to a lower resolution, because 0 millimeters? That's not right. Oh, I'm not used to. Maybe advanced is closer. Where? How do I? I'm not familiar with this, so I'm not familiar with this program, so I don't know where this one puts like layer height. You notice that there's no layer height in this profile. This profile here isn't designed to be printed directly off. It's supposed to be a like a basis to make your own profiles, but you know how I am with having time to do stuff. The setting controls the height of the I thought when it said base layer height, I thought it meant like the base layer, like the bottom layer. Right. Let's see. I always like to make the first layer 0.2 millimeters, because there's no. I mean, as long as it's the same. As long as it's the same across multiple prints, then you can easily eyeball it. Let's try doing this at 0.15, and let's see how long this takes. So this is going to take 13 minutes. So let's crank that quality even more. I'm going to change the first layer height as well. Slicer on up. All right, 20 minutes. I think that's fine. Alrighty. So the workflow here is a bit different than I'm used to with my Prusa, because as far as I know, you can't upload directly. So we don't need. So like, one cool part is we don't need Octoprint for this, right? We don't need Octoprint because the printer itself has Wi-Fi. We already have some filament loaded in extruder number 2, so we don't need to worry about that. Oh, I wonder if this works with the Space Mouse. I wonder if Super Slicer. Yeah, Super Slicer works with the Space Mouse. Nice, nice, nice. All right, so we're going to export the G code, and then we're going to put it in manually. So check this out, and then we'll open up Squirtsephony. We'll hit the upload button, and let's grab it. I just hope it heats up first. Check this out. Oh wait, we got a boo boo. Oh, what do we got here? Among Us keycap response to long C console. What does that mean? The height map is loaded when the current Z was not. Oh, it can't print it because we're not homed. Well, it's fine. That's good because we had a problem anyways. Yeah, the problem was printing off heat off. Let's see. It was all right. So what's going on here is it was sliced to print off of extruder 1, but that's not what we want. We want extruder 2. So we've got to. I thought, but it should have printed. We'll see what went wrong, because it should have printed it off extruder 2. Let's see. Yeah, why did you use the wrong tool? That shouldn't have happened. Let's see. We want this to go off. So it's calling it extruder 2, but it's actually extruder 1. It's a real thing. Yes. Chloe. We are going to print a keycap on an FDM machine. That's right. So yeah, it looks like it doesn't home automatically. I gotta mess around with that G code. Yeah. So let's home it up. You'll notice I'm doing all this on the computer, not the printer, because the printer doesn't actually have any sort of controls on it at all. So, yeah, one of today's projects might be making a physical control panel that we can put on the printer so that I don't have to rush back to a computer every time I want to, every time we want to, print. All right, let's home this. Let's see if I can actually I should replace myself. Let's just. Oh, the auxiliary camera just flopped sadly down to the ground. Womp womp. Let's actually switch over here and let's zoom back out so we can actually see all the action as we start off our print. I'm actually going to raise this up a little because, in my opinion, it's cooler to watch from overhead. Yeah, you'll notice that I have the enclosure open. That is intentional. We don't. Yeah, that's intentional. You don't need an enclosure when you're printing. You don't need an enclosure when you're printing PLA. It doesn't help, and if anything, it increases the chance of having an early jam. So let's start by homing. I've edited the homing script so that now it won't destroy the plate if it homes when there's a tool already in place. Oh, did I ruin it? I was doing some work on this, and I think I just forgot to. Hang on a second. I was doing some work on this, and I think I just forgot to save the script. This is not a beginner-friendly printer. It's not designed to be, and it's certainly it's not designed to be, and it certainly is not. So it gives you lots of ability to shoot yourself in the foot. Let me switch back over so you folks can actually see. Ignore the on-screen keyboard. I set that up because we're gonna need it for the. I set that up because we're gonna need it for the control panel, but I don't know any way to get rid of it, and it's preventing me from seeing the rest of the script. So I don't really know what's going on there. I'm just gonna rip this off and drag it over to my other screen to work on it. Okay, why isn't this working? Oh, it's not. Oh, it refuses to park the tool. All right, yeah, this is all right. So we've caught ourselves in double bind here because it thinks it's picked up a tool, but it can't return the tool until it's homed itself. Because I haven't updated those scripts yet. So let's hope that this doesn't destroy anything. All right, cool. So now this should home properly. Home Y, home X. Y. All right, so now it's homing the C-axis, the coupler, and now it should move to the center and home the Z-axis. There we go. Excellent. Alrighty. Cool. All right, let's get this out of here. This is the Duet web interface running on the onboard Duet board. I don't think we're going to use Clipper for this because a lot of the built-in scripts like that were already written by E3D are using the RepRap flavor of G-code. So we could port I don't think it would be a lot of work to port everything over to Clipper, but it would cause a lot of bugs that would have to get fixed. So for now, we're going to stick with using RepRap firmware. So yeah, we've let's just double check here. So let's export this again, just in case. So this should now be sliced for extruder number 2. What's going on here? What? It shouldn't be red. This should be. Hang on a second. What's going on here? This shouldn't be red. This should be green. Red means extruder. What? Hang on a second. What happened here? Is this printing one of them inside the other? What the hell is going on here? What? How did this even happen? Extruder 2. I hope this is a. I'm gonna just quickly change the infill to force it to reslice. I hope this is just a problem with the system. what's going on here? Why is it... Is it printing support material with extruder 2? Because it shouldn't. It should be printing... It's printing support... All right, so what's going on here is it's automatically printing support material with the second color filament. And it's printing... We don't want that. So let's see. How do I change this? Multiple extruders. Let's see. Oh, okay, here we go. The extruder used when printing perimeters and brim. Okay, so we want to, for now, print everything in extruder 2. We're going to... this affects the raft. Let's see. So this thing does not need a wipe tower. So it's still splitting the print between the two extruders. I don't get it. Like I said, we're gonna have some trouble. We're gonna have some problems today. Multi-material tool change enabled. No, we don't care about that. This is basics. All right, this is nothing we care about here. Yeah, this is part of the fun. Yeah, I guess we could load. I guess we could load filament. Let's see. SP Roach suggests that I ordered a color change, but I'm not seeing any of the markers. Usually this is where, I see this is where that happens, and it makes it look like this. That's not what we've got. Yeah, we're working on. I'm working on it. We're trying. Yeah. This. I hope you folks don't think. I know no one likes watching me struggle with stuff, but I have put a lot of hours into getting this thing to work. But it seems like we still haven't. Seems like there's still more that I need to learn. So I'm going to turn off supports. Maybe that will make it behave better. Yep, it looks like we're now printing exclusively with extruder 2. At least now we know it's going to be really easy to set up support material. All right, let's export this guy. Yeah, let's export it. We're going to tab back over to Squirt Stephanie, and pardon me, we'll upload it. All right, and it should start printing automatically. Oh, wrong button. All right, it's picked up tool number 2. It should be heat. Yeah, right now it's picked up the tool. It's heating it up to 200 Celsius. I think I want to edit the G code so it heats it up before picking it up. I feel like that's better because then it would drip the booger down below the bed. Yeah, let's here. Let me tab back to that. I am forgetting what all of my controls are. Ah, there we go. Excellent. Yeah. So it seems by default it was configured to. So it seems like it was configured to get to print supports with a second extruder. And I've never done any multi-material prints before. In fact, I don't even think I own anything printed with a multi-material. Yeah, today's is good. Well, so yeah, there are going to be some hiccups, but this is an excellent time to announce that today's stream is sponsored by Things.com. So whatever things you are interested in building, or whatever things you're interested in printing, Things.com has you handled. As we did earlier today, you can even use it to search other 3D printing sites. So even if the thing you need isn't on Things, first off, you should put it on there. But second, it searches the other sites as well. And what I like about Things is that it makes it super easy to upload files. It's super easy. Just download, just like hit upload, click your file, and it automatically generates a preview. You don't have to take a picture of it. You don't have to do any of that stuff. It automatically populates it with a name and everything, and it automatically generates a whole bunch of thumbnails and stuff. And you can even upload whatever license you want. Yeah. So regardless of why you put stuff online, things.com's got you covered. So let's get back to the printer and watch it in action. So let's see. First layer looks a little rough. Maybe I should have cleaned the bed off. I'm a little hesitant about spraying too much alcohol around in there because alcohol attacks acrylic. But let's see. Let's let it run for the first few layers. You'll notice that after it passes about the third layer, it's going to speed up. I actually decreased the speed a lot because and we're having a problem where it was shaking the far right tool off of its dock. But yeah. Currently, we are printing. Ego 1966 asked, "What are we working on right now?" We are currently printing a keycap to test out our printer. Yeah. So we'll see how well it works. This printer isn't dialed in very well as of yet. We need to do PID tuning of all the heaters. By the way, you're hearing that part fan now, right? Like the thing is crazy strong. If this printer is too loud, I'll switch back over to the headset. So, a few folks are asking, what makes the printer ultimate? Well, it's a CoreXY printer. It's got 4 extruders. The bed plugs directly into the wall. It's 120 volts AC bed. What else? One of the extruders is liquid cooled. 2 of them can print up to 450 Celsius. It's got Wi-Fi. It's got lights. It's got RGB LEDs. I haven't hooked those up yet. Pretty much any way there is to go over the top on an FDM 3D printer, I've gone over the top on this. Some folks were asking what CoreXY means. Here, check this out. You see that the bed is staying in position. The bed moves up and down, but it doesn't move in and out like it does in a Prusa. And that's the nature of the CoreXY printer. The CoreXY printer drags the head on the X and Y axes instead of just on the X axis. And one of the advantages of this is that generally the Z axis is the physically heaviest. So this allows it to whip that head around a lot faster. This is another thing that a CoreXY does is it uses 2 motors to control the X and Y. But what's weird is that one motor brings the extruder forward and to the left. The other brings it backwards and to the right. So in order to move diagonally, it's only using one motor. And in order to move, in one direction, it's using both motors. And that all these factors allow it to print a bit faster and also reduce the amount of ghosting and ringing. Although this printer is going to have a lot of ghosting and ringing because it's not very tuned. Because of how heavy the extruder is, because it's got the Toolchanger mechanism as well. Getting your linear advance is for extrusion, but basically getting your acceleration settings set up properly is much more important. Let's see. Wadusei asked, does that reduce vibration? No, CoreXY printers are actually pretty vulnerable to vibrations. So, yeah. Di Rylan asks, what would happen if it drops the extruder on the bed? That wouldn't be the end of the world, because if it drops the extruder on the bed, it would just fall off. The problem would be if it drops the extruder off the side of the bed. So I actually have some foam blocks on the bottom, just in case. Mikey Osterhot asks, out of curiosity, if I wanted to buy this, how much would I have to pay? That is an excellent question. The base model, just the Toolchanger, I think is 1,800 quid. It's in British pounds. Input shaping. Christian Marino is right. Input shaping is what I was talking about. Which the Duet, I believe, can do. The new firmware has some of the Clipper style input shaping. It's actually very sophisticated. I'm really impressed. Let's see. I've been asked to move the camera down a little. Sure. There we go. Yeah. So, what was the question I was answering for? Because it was a good one. Oh, how much does it cost? So I believe in total this thing would probably be around 4,000, maybe, because I put a bunch of upgrades and stuff into it. I think it would be somewhere in the neighborhood of $4,000 US, give or take. Which, now that I'm thinking, like, I've been imagining that, I've been like conceptualizing this as like some really crazy expensive printer, but like that's expensive, but it's not over the top expensive. Like my first maker bot cost almost, like, that thing retailed for like $2,200, and that thing was, I mean, I guess it was good at the time. I believe that's also a CoreXY printer. I think the maker bot was definitely a CoreXY printer. All right, so folks are asking about the fans. Let me pull that up. Yeah, hang on bear with me one sec. I got to pull it up in my email because I don't remember the name of the. Let's see. I remember it's made by a company called EBM Pabst, but I bought it from. It was really. Let me see. Who did I buy it from? I bought it from some company I never heard of before. Pabst. Not Pabst. Why is it that, like, when people are watching, it's impossible to type? EBM. Come on. No, not that. That's the fan. Alright, bear with me one sec. We're going to pull up Discord, because Rene is the one who initially told me about it. So he definitely mentioned it. Oh, but we've been talking so much, it's been pushed all the way off, like, the edge of the earth. Don't you hate it when that happens? Like, you're looking for something someone said, but you're looking for something someone said, but, like, you've been talking a lot, so it's got pushed all the way off. Where is it? The Pabst blower fan. Where is it? Oh, it's probably my search history, right? Yeah. EBM Pabst. Oh, here it is. Let's try not to dox myself, and here we go. This is it. This is the name of the fan right here, the RLF 35-8/14N. Yeah. This doesn't have any of the spicy. This doesn't have any of the spicy data. Oh, nope. Link's broken. Yeah, we want some of that spicy data. Where is it? Let's see. It's pretty beefy. Oh, it's a 4-watt fan. 6700 RPM. 5.5 cubic feet per minute. This little blower fan moves as much air as like a 70 millimeter like PC cooling fan. Yeah, the thing's bananas, and that super big duct you see at the bottom. You can see it better in the ones that are still, the extruders are still in the rack. That super big fan concentrates it right, like it sprays it right onto the part. So the quality of this thing should actually be quite good. Yeah, it's pretty. It's pretty impressive. Am I glad I did the upgrade? It added a lot of work, but I'm glad I did it, because this is the ultimate printer, not the penultimate printer. If there's something we can do over the top, we're going to do it over the top. You'll notice that the Titan extruder to the left does not have any fans at all, and yeah, I mean, it's water cooled, so it doesn't need an extruder cooling fan. But remember, the whole reason it doesn't have an extruder cooling fan is because it's designed to be used in a heated enclosure. So there's no point having a part cooling fan either, because it's just going to be blowing hot air onto the part. So, yeah. J2D2 says it has no RGB. It actually does, and one of today's possible tasks could be to hook it up. I added some ergobled strips along the sides, like a jukebox. So we could hook those up and make it ergobled. I couldn't really figure out where else to put any, but we certainly can try. So we have a number of options of things to do today. We can build a control panel. We can hook up the ergobleds. We could focus entirely on running more prints. We could say, screw it, I'm sick of this project, just move on to something else. So, yeah. A few people are noticing that I am using Edge. Yeah, that's right. I've switched from Chrome to Edge. First off, because I'm getting a little uncomfortable with Google's buddying up to certain foreign governments and their data collection practices. Edge does collect data, but it does it through Windows telemetry. So if you have group policy enabled, like if you're using Windows 10 Enterprise, Business, or Ultimate, I think, you can set up a group policy to disable telemetry. Which, you know, it's I trust that I trust Microsoft to not screw over its enterprise partners. On top of that, Edge is way faster than Chrome. It's they're both based off Chromium, but it's much faster. It loads some pages up to twice as fast. The program itself loads up in less than a second, and it uses less memory. It uses a lot less memory. Edge is sort of Beefing It points out Edge is Chrome, so Google controls what web standards should still be enabled through Edge. That's right. But at this point, like, pretty much everyone is using WebKit, right? Like, at this point, like, that's fairly, I don't know, like, on one hand, yes. On the other hand, Google's actually been a fairly good custodian of the web. Yeah, I don't know. I don't think they've been so predatory with regards to the standards, but yeah, I've heard Opera is good. I've heard a lot of people are talking about Brave. I could try Opera. Brave is a bit heavyweight. Yeah, there are a few. Dot to the Lock says even the iPhone uses WebKit. The iPhone doesn't just use WebKit. Apple pioneered WebKit. They were pretty much the Safari is basically the most standards compliant web browser that's ever existed. So as weird as this sounds, if you're having trouble with a web page, you should always load it in Safari because it'll almost always work. There's this web benchmark that detects how standards compliant your browser is, and yeah, Safari's the only one that always scores over 95%. So yeah, it's actually Apple is dead set hardcore on rigorously supporting WebKit. Opera and Firefox both have some shady partners. Trickster Zorua points out, "Hey, Rene is here. We're about to see this print come together. So let's see. Let's stick around for the next how long? For the next 3 minutes and 48 seconds. Oh, look at that! That is a very consistent. It's a very consistent time estimate. I think it can do G-code visualization, but I'm a little worried it'll crash the Raspberry Pi if we put the control panel on this. Look at that! Even in the corner up here, it even shows it changes the favicon to a little pie chart. Ah, that's so cute. Ah, I love it. Very nice. Ah. Very nice. Let's switch back to our printer. Ah, look at that! Isn't this nice? Yeah. I'm going to be honest. I'm really impressed with the Duet board. The documentation and the web interface are both really, really excellent. I'm really satisfied with it. Working with a Prusa with raw G-code isn't the most enjoyable thing to do. Yeah, I'm drinking Mio. I didn't have time to brew any tea today. Yeah, I suppose we're asking for a camera on the print itself. I'm gonna try. That's gonna be tricky. I'm gonna try. It's gonna be tricky though. Here, I'm gonna turn this to the side while I mess around with the tripod. This tripod doesn't go very low, so I'll do the best I can, but we might have some trouble. Let's see. Yeah, I can't bring the tripod down low enough. Let's see. Yeah, this is the best I can do. Unfortunately, the tripod is quite tall. I do need to get another. I have to figure out how to hook a camera up to this because the bed the bed goes up and down, right? The bed itself moves. So I would need to attach the camera to the bed. The problem is that there's already, like, the extruder has to move around off the bed a lot in order to pick up tools and stuff. And so I don't actually know where I would mount it. It is a problem to solve, though. It's the challenge is, so what's neat is that this flavor of G-code actually has a take picture G-code, which is it's pretty sick. So getting this thing to actually take the pictures, if I attach the camera to the bed, would be as easy as just adding in that G-code on in the on layer change in the slicer. Yeah, it does look like nothing's being printed, but you know, it's the nature of having a large encoder. I think I might. Another thing we could do today is we could take like an endoscope or a borescope and attach it to the extruder so that we can get a sort of get a peek under the extruder. And we can mount a camera to the tool head. That's another thing we could do today. That could be pretty neat. This thing actually has the ability to put in a webcam. So, Chris Leach, thanks a lot for the 10 Canadian pesos. Best regards. Best regards to you too. Thank you so much for the super chat. Every little bit helps. It all supports the channel and goes towards making crazy projects. That's another thing we could do today is we could start working on the next video's project, and let me tell you, it's a doozy. The next video's project is going to be excellente. Let's see. I don't want to start picking up the camera right now because we're getting close to being done. We only have a few minutes. We only have like a minute or so left. So yeah, you know what? Let's here's what I'm gonna do. I'm gonna try taking the auxiliary camera and putting it on. Let's see. I'm gonna try taking the auxiliary camera and putting it on a USB extension. I am skeptical that this will work because might not have enough power. These cameras draw a lot of power, but it's worth a shot, right? It's worth a shot. Worst case scenario, it just don't work. I guess worst case scenario is it crashes the stream. I got to rant about why the last stream crashed because it's a real situation. Alrighty. This is not frozen. This is let's see. Maybe if I deactivate it and activate it again. Looks good. Looks good. Let's see. Okay. All right. Looks like we are on the move. So let's see if I can smash this against there so you folks can see it. Yeah, there's going to be some artifacts. Going to be some tearing because of how long the cable is. But yep, it is definitely printing. Check that out. The last stream. So in short, the last stream crashed because the USB microscope was a piece of garbage, and it was deadlocking NVIDIA's hardware decoder. Basically, like H264 video, like the kind coming off the webcam, is decoded by the graphics card, and it was hanging the graphics card, and that was in turn hanging the rendering thread of OBS. And OBS was reporting the wrong thing. It wasn't reporting that the thread was hung. It was reporting it was missing frames. So I thought it was a connectivity issue. So yeah, that problem should never happen again. I have taken care of it. So yeah, let's try to get in and around here a little bit. Let's see. Take a look through the other side. Yeah, so it's sort of like the extruder is like backwards in a way compared to like what you'd be used to with another printer. Yep, and there it is. That's how it docks it. And that's it. That's it. Check it out. Is that sus or what? Here, let's disengage it. Oh, there we go. Focus. Look at that. that's it. That's our first on-stream print on the new Toolchanger. So the quality isn't great. It looks like our Z is looks like our Z-axis is homed a little low, a little high. It looks like the nozzle's a bit too close to the print. Let's check the sides. So you can see some ringing. Yep, see that? See those ripples? That's caused by ringing. We got to adjust our acceleration a little bit. And let's check underneath. Oh, I didn't even need support. Let's see if we can get this to focus. Focus! Come on! Getting these webcams to focus is the worst. There's no way to manually focus it close. It only manually focuses at range. Come on! Come on! Be good. Come on. Alright, so look at that underside. That is perfect. That part fan, that super powerful part cooling fan is doing some serious work. And now it's not focusing there. Alright, awesome. That part cooling fan is doing some major work. So yeah, I'm satisfied. I guess the next thing to do is to see if it actually fits on a keyboard, right? Yeah. I mean, I suppose that's the next thing to do. So first, hang on 1 sec. So let's move this over here so we can see the keyboard. Ah! We fell over. This tripod that was packed in with the camera is a complete piece of garbage. Look at those happy anime ladies. Look how happy they are. They're happy that we managed to get our first successful print done on stream. So we're gonna trim off the brim because it's not going to go in without the brim. And let's see if I can just grab one of these keycaps and yank it off without having to go digging around for my keycap upholler. Let's see, the corner ones usually, yep, there it is, easy to take off. Let's see, this might not fit because the stem on this is a bit thick, and these box key switches don't give us a lot of room. So let's see. Yeah, it's not fitting. All right, so let's try instead to swap out a key on our macro pad, and let's try to pick one that's not going to have a side effect when we. I forgot which key mutes myself. Oh, geez, Rick. So let's pull that keycap off. This is going to be yep, here it is in our keys bin. This is why I keep everything organized. Let's see. So let's get this keycap off. There we go. Focus. Come on. It's like trying to get our dog to go back in his kennel. Alright, and let's try our brand new sus keycap. There it is! Perfect fit! Still got a little bit of brim left on it, so it's jamming up a bit. But yeah, there we go. Look how sus that is. Ah. That is as sus as it gets. I missed a pair of super chats. I was too preoccupied with our keycap. Loy Chloe C, I hope I pronounced that right. Thank you so much for the CHF. Thanks, Zack, for all the great content. I love it. Are your previous live streams available somewhere? Yes, all of our live streams are available for patrons. Visit patreon.com/Zack Freedman, and anyone who's a patron gets access to all the past streams. In fact, if you don't even need to be in the lowest tier, right? Like, as long as you donate even a single whatever your local currency is, you'll get access to all the stream archives. It's our way of rewarding people who support the channel, and also keeping our old streams from screwing up basically screwing up our rating on YouTube. The worse your videos do in terms of total views, the less Google recommends your future videos, and they don't care whether that video is a stream or not. So yeah, in order to make sure that people actually see all the stuff we do, I got to unlist the streams. But yeah, as long as you donate even the tiniest amount to our to the Patreon, you get access to all that. Also, for the next few days, I'm going to be leaving up this entire series in the live streams channel on our Discords. You go to discord.gg/Voidstar Lab, and you just go on the live streams channel, and you can bookmark all of the past streams in this series. I decided to make them available because we've been having a bit of stream trouble. So, oh yeah, Jose Acosta. Thanks a lot for the bucks. He says, that looks nice. Try opening your hand behind the keycap so it'll focus. I think it's, yeah, now I'm thinking about it, maybe it like picks up on human flesh tones. Maybe that's how it decides where to focus. Yeah. 3D printed keycap pullers is J-Cop guy. It seems obvious. Seems obvious, doesn't it? But yeah, thank you very much for the very generous super chats. That makes the your support makes our projects and stuff possible. What's causing the key to wobbles? Asked Bob Weirham. That is the stem itself. These are Gateron keycaps, and they're not tremendously high quality. The tolerance is not the greatest. So you see that even the professional quality keycaps are wobbling as well. This one looks like it's wobbling more, but it's actually just much taller than the other keys. So awesome. We've done a print. I can't. I see. I'm seeing why I can't switch back over to our other camera because I unplugged this, so I wouldn't mute myself a second time. Boop. So yeah, our print is done. Our tool is returned. I just want to give this a quick check to make sure. Yep, this tool right here is much heavier than the others, and it likes to wiggle loose. So yeah, it likes to wiggle its way out. So might have to think of something clever. I have to think this something clever to to deal with that. The best solution. All right, so the best solution for getting a macro shot with the webcam is just to replace the lens in the webcam. And there are kits. I haven't got around to it. I also have a macro lens. Like we could just throw it in there and whatever. All right, so now we have a few options. We've done our print. Yeah, we finished our print, so now we have a few choices. Rudy Niemeyer, thanks a lot for the euro. Thanks for continuously entertaining and educating. Thank you very much. I really appreciate it. I try to be a little bit of both. I think the streams are a little more educational and the videos are a little more entertaining. I'm trying to get them in the middle though. I think the last video came out, but I really appreciate the encouragement. Internet can be a mean place. Every little bit does help. Thank you very much. So, let's figure out what we're doing next. Okay, I'm gonna get over here and I'm gonna adjust this here camera so I can show you what's going on. Let's take a look at the parts for the control panel. That'll help guide our decision on whether this is what we want to do with the rest of today's session. Pogler McPeriwinkle, thanks for the $5. I like your name. I like your deep fried Little Caesars profile pic. All right, here's what we're messing with. He said, trying desperately to avoid swearing. So this is. Let me turn this. Let's just turn this around. So this guy here is the same display that I used in the Data Blaster. This is a 1280 by 480 display, like ultra widescreen that I used in the Data Blaster, and I have a spare. So we can turn that into a control panel. I've actually already done all the hard work of this. I've already configured the Raspberry Pi to configure the touchscreen. I've got the resolution dialed in, and we have it automatically uploading. We have it automatically opening the Toolchanger's web interface when it boots. So the only things we would need to do are design and fabricate a case. And I realize that I'm way too close to the mic now. So we have to design and fabricate a case for it, and then we'd have to print that and actually install it. So it is capacitive touch indeed, Mr. Bonts. Let's make the all right. Let's make the control panel. Yeah, let's do that. So the control. So here's what we're gonna do with the control panel. We need a way to mount this guy. So we're gonna take this guy and we're gonna mount that. And we also, what I'd also like to do is, instead of having to upload files over the internet, I think I'm going to take this. Yeah, I think we're also going to add in this USB reader. So we can either just slap that on the side, or we can. Let's just slap it on the side. Makes life easier. Raju Alexi, I hope I pronounced that right. Thanks a lot for the RON. Man, I gotta learn all these abbreviations. Dieter Benut, thanks a lot for the euro. I really appreciate it. So let's get down to business. Yeah, let's. We're gonna model. I'm gonna open up. All right. So here's what we're gonna do. We're gonna bring this back over to the other side of the table. We're going to open up the Data Blaster. Yeah, we're gonna open up the Data Blaster model. And we're also going to lower sound a little bit so I don't blow your eardrums out. We're going to open up a Data Blaster model, and we're going to pull the dimensions for this. We're going to use that to design our control panel. The control panel itself is, I'm thinking of mounting it like right here. Although then again, like, we're going to have this thing open a lot, so maybe that's not the best idea. Let's see. We could also mount it on the door. Or we could just mount it right here. That seems kind of the obvious choice, right? This thing isn't going to live on the floor all the time. It's going to live on the yeah. It's not going to live on the floor all the time. It's going to spend a lot of its time on a desk or a table. I need to actually buy the table. So I'm thinking we make this thing screw into the extrusion. Yeah, I think it's the way to go. Heyo. That's what my chin looks like. If anyone's wondering, that's what my chin looks like. Yeah, let's switch back over. Switch back over here. Okay, cool. All right, let's do that. So I'm going to unplug it from the Raspberry Pi. Yeah, I want to model the cables in with it. So just gonna move this over here. Squirt Stephanie. Oh, some folks were asking what project we'd be working on for the next video. Okay, you know what? I think it's fair. I think it's fair to give you folks a little sneak peek. So one of the most common questions I get asked, and as esoteric as this question sounds, it is one that I get asked very, very often, and that is, can you make a heads-up display? Can you make a wearable computer using a transparent display? And the short answer is no. The long answer is hell no. But I get asked this question so many times that I've decided to do it in a video. Yeah, we are going to. Yeah. So yeah, that's hopefully the next video is we've got some transparent OLEDs, and we're going to build a heads-up display that doesn't work. So we can teach a little bit about optics, and mostly so that I have something to point people at, because I'm sick of answering that question. Dia Della Toala, thanks a lot for the Argentinian money. I'm here to claim the title of biggest Freedman fan in Argentina. You're awesome, man. Thank you very much. I don't think I have a lot of Argentinian fans, but not that you hear me complaining. So let's open up. Thanks a lot. I really appreciate it. You folks have been very generous today. Every little bit helps me make awesome projects. So let's open up Fusion 360 and get ready to rumble. This time I have rescued my calipers from Brooke in advance to prevent her from calliping, unduly calliping. Another option here is we could run off another print while we wait, but we don't really have anything lined up. So I don't know. I think that would just be a bit of a waste of time. So hang on a second. We're gonna open. Seems like I closed this down without saving any files. So let's see. Boop. I might switch the resolution back because it's not the easiest to work with Fusion at such a resolution, but we'll keep it here for now. We'll see what happens. So I've got my space mouse. That's why everything's flapping around. This is the brush that I modified to fit a Harbor Freight. This is a wiper that I modified to fit the Harbor Freight brush. The Harbor Freight brush is a little thicker than the one that whoever designed this model used. But we're done with this, so we're going to close it. Let's see. This is the little PTFE coupler that I use because I snipped the filament guide a little bit short. So here we go. PTFE coupler, 4 millimeters. All right, let's get that out of here. Alrighty, so let's open up the data blaster. Where did I put it? I put it in the Voidstar Lab trappings, or did I give it its own project? Cyberdex. There we go. Data blaster prototype version 79. Almost. Alright, so this is it. This is the data blaster. You can see that I actually made this one color correct because I was not 100% sure, color and texture correct, because I wasn't 100% sure about that color scheme. So this part here is what we care about. Yeah, this part here, that's what we're looking for. Brooke says, yeah, make Zack get better at stuff. Yeah. Hey, it matches. So yeah, we're gonna copy these dimensions down and use that to make our thing. Yeah, one of the cool parts of building projects is one of the cool parts of building projects is that you start building up a library of parts, a library of dimensions. So as you build more projects, future projects get easier. Yeah, this text is barely. This text might look fine to you, but it's barely legible for me. So I'm going to switch the display density back to normal. You know what? Let's actually, now I'm thinking about it, it probably makes more sense to split the difference and just make it like a little bigger for all the folks in TV land. So yeah. Bfingit suggests if you copy parameters in Fusion 360, often parameters IO is an official add-on that'll save your life. I gotta give that a look. But for now, I think we are going to copy the entire sketch. Then we'll just delete the geometry we don't care about. So let's see, new design. We're going to make a new sketcherino. Paste that in place. Where do we want our zero? Where do we want our 0 point to be? Let's call it the inside corner. So this corner right here. The Space Mouse is good. I like it a lot. I definitely need to get more practice with it, though. There we go. That should be almost fully constrained. I definitely need to get more practice. So now we're going to delete all of the geometry that is unrelated to our current project. We only want the slot for the we only want the slot for the display. I keep forgetting that I have to line this up in a different way. So yeah, I appreciate everyone for coming back after last. Appreciate everyone coming back after the last stream's unsatisfying end. I am super duper salty about that one. Yeah, we don't need any of these slots or anything. Get those out of there. We don't need any of this internal geometry. Although, hang on a second, we're actually going to hang on to this. We're actually going to hang on to that because we still have wires and stuff. Where did I even put the display? Was I just like schlepping it around and threw it somewhere? Did I put it on the floor? Oh, yep. I just dropped it wherever I could. So, yeah, these little cutouts here are all the stuff in the back of this. It's giving us relief. For our wires and stuff. We're actually going to add a little more off the side for the USB cables. You'll notice that there isn't a lot of. So this right here is a bit of relief for the ribbon cables that we use in the data blaster, but that's where we need more. It's okay that I'm using an educational license, Tillman. This is education, isn't it? Oh, come on. This is basically education. Come on. This. It's the same thing. Shh! Don't tell anyone. I don't like software. I don't like software as a service business models. I don't like supporting them. I guess I am implicitly by you know, using this, but gotta pick your battles. Alrighty. So yeah. So check this out. So this is mirrored. So yeah, this is what these dimensions are representing. So we've got we don't care about the audio, right? We don't need the audio jack. In fact, so fun fact with the Singularitron or with the Data Blaster, I added, like, you see, I modeled in the sketch a place to plug in the headphone, but I just completely forgot to extrude it. So straight up, there is no reason at all you shouldn't be able to plug headphones into the Data Blaster, except that I'm dumb. So we don't need this anymore. We're gonna get rid of it. Boop boop ba-doop. Let's re-add our dimensions. Oh, pardon me. The pollen is really nuts. What is this? What are those? The pollen is completely nuts here. It's terrible. Alrighty, so let's just confirm. Let's confirm our sizes here. First, I'm going to confirm this, or confirm our dimensions. First, we're going to confirm this one here, 17 millimeters. It would help if we turn on the calipers. My calipers need to be zeroed. I think the battery must be going. It starts to lose its zero when the battery goes. Come on. Pushing the origin button. There we go. All right. So this is closer to 21. Yeah. Yikes. Yikerinos. So let's change this to 21. Why can't I change that? Oh, that's stupid. Why is it doing that? So let's see. Let's move this over a bit. All right. So we want to change this to 20. Why is it letting me change this? What? I set up the dimensions like a total moron here. Why is it still not letting me change that? Yeah, this is what happens when you don't think through how you structure your design. Yeah, you know what? We're gonna leave that. We're gonna leave that the way it is. We're gonna leave that the way it was before, and I am just going to add an extra pair of lines to. Yeah, we're gonna add an extra rectangle here to pad this out a little bit, so we can, you know, actually plug in our. So we actually plug in our HDMI cable. All right, so we want this to be centered. So this segment and this segment are going to be equal, and we want this total to be. Oh, hang on a sec. There we go. Yeah, we don't want this. We don't want these to be at an angle. That would make life a little awkward. So yeah. Want 21 plus display. What do I call this? And let's call this 21 for the size of it, plus an extra 1 to give it some clearance on both sides. Just make sure this worked correctly. All right, perfect. So that should give us some room. We let's see. Next thing we want is. I want to leave some room for the bottom of the HDMI cable. We'll add in the holes. I think we'll add in the hole later. Although, you know, no reason not to model that in now that I'm thinking about it. All right, so this is about 42 millimeters, and we already have a dimension. We already have a dimension for this. At least we should. Yep, here we go. So we want 42 instead. Yep, there we go. Alrighty. Let's add in a center line. Let's add in a center line here, and there we go. And this is going to be for the cord. And for the cord, we want a relief of about, I'm just measuring this in my lap here, let's call it 11 millimeters. So it looks like we were fairly close in the first place. And how much relief do we want? This doesn't really matter so much, because we're probably gonna like fill part of it in. But let's call this 15 millimeters. All right. So cool. All right. So this gives us. So now we have our cutout. We now need to build the rest of the. Frame. There are a lot of dimensions here. That's just because I copied down. Basically, like I drew an outline of all the places on this that don't have parts. So yeah, all the places in this that don't have parts. So that's what that is. Oh, I just realized I need to update our to-do list because we have made some progress. We did our print. We did our tour, and now we're making our control panel. There we go. Yeah, there we go. So yeah, let's make our control panel. Okay, so we want to add a bit of a rim around this. Let's there's no good rule for like how thick that should be. It comes down almost to like aesthetics. I'm gonna do 3 millimeters for this one. So this looks like we're giving ourselves 0.25 millimeters of clearance. See, 0.25. So we can't offset and offset. So we have to offset the original. We have to offset the original curves. We're going to call this 3 plus 0.25. All right, and that gives us the body of our. Our dingus. Yeah, and we want to probably just. Let's see. So we want to extend this a bit. Yeah. Here's what we're going to do. So we're going to extend this a little bit to also cover the bottom with the... I think we should also cover the bottom with the... Let me think. We either cover the bottom with the cables or we just have the cables like just poking out of it. I guess they'll have to poke out eventually, right? So here's what I'm thinking. We do want to have it poking out the bottom, but I don't want it to poke out all the way. So let's just call it let's call it 20 millimeters. Let's call it 10 and see what happens. So most of the HDMI cable is going to be poking out the bottom. So I think that will be a-okay. For a USB, let's make this bigger so that it goes all the way to the edge. Alrighty. Cool. So this part we need to make this collinear with this part, and then we need to round the corners. So let's miter and miter. Why did it get rid of the dimensions? That's weird. All right, we don't care. So we're gonna miter this, but we don't care. Yeah, we're gonna round these corners, but we don't care about the dimensions because in order to make this visually consistent, I am just going to make these equal. There we go. Cool. That's it. Are we forgetting anything? Are we forgetting anything? There's a button on the back. I still have no idea what that button actually does. It doesn't seem to turn this on or off or any of that. So we're not gonna leave a cutout for a button if we don't know how it works. We have a bunch of data lines on the back. We have an RX and a TX, and we also have a serial clock and a serial data. And really, at some point, I really want to sniff, really want to like hook up, logic analyzer or something and bus pirate and sniff that. So, anyways, this should give us a start. I realized we forgot something. Yeah, folks, we forgot something rather important, and that is how we're going to mount the top to the bottom. Oh my! All right, so we have to actually. Oh, geez. When the space mouse, like when it gets turned sideways, like when it physically gets turned sideways, it causes all kinds of weird stuff to happen. So pardon me. All right, so I'm just going to do just the same thing I did before, where I'm extending the side. We're going to do that on the other end, and yeah, because I need to give myself room to mount the screws. So let's miter this guy. I don't know why I'm having such a hard time selecting points. Doesn't matter what the dimensions are because we're just going to be making them equal. So this is going to be equal to this. This is going to be equal to that. Overconstrained. All right. Oh, they're already made equal.
I have a message from Cyberdeck Cafe.
I have a message from Cyberdeck Cafe, according to Brock.
Let Zack know the button on the back of the display rotates the touch screen overlay. He needs to leave an access hole for it. It's super important.
All right. So Brooke just says Cyberdeck Cafe told me that pressing the button rotates the touch screen. That would have saved me a tremendous amount of time with the Cyberdeck. So yeah, I guess. Pardon me. I guess we could leave a hole for it. Yeah, I guess we'd leave a hole for it. I don't. Beefing it says I like clips instead of screws for putting parts together. I don't really like them. They wear out. There's no. So if you think about it, right, we're gonna have to. All right. So, pardon me for sneezing too loudly. So if you think about it, we're gonna have to print the faceplate flat against the bed. We're gonna have to print the back part flat against the bed, and that means that the clips are gonna have to face upwards. So the layer lines are gonna be like perpendicular to the clip, and that puts a weak point, the weakest part of the clip. So I don't think it's appropriate for this particular project. Oh, pardon me. This hay fever is awful. Yeah, so we'll remember to put a yeah, all right, we'll remember to put that in. 10. Actually, we should probably make. Let's see. Okay, so here's what I'm going to do. We're going to add construction lines on both of these, and that way we can make them equal, and we can also, like, register our. We can also use them to line up our screws. So we'll do that. We'll do that in a sec. Okay, it looks like we have enough. Looks like we have a lot of dimensions here. So Fusion's starting to slow down. So now is an excellent time to save. So Voidstar 3D printers. We're going to call this E3D Toolchanger Long Boy Control Panel. We're actually going to be using this thing in portrait mode because I tested both portrait and landscape, and the web interface actually renders better in portrait than it does in landscape. So yeah. I think we're going to do... You know what? I wasn't planning on doing heat set inserts for this, but now that I have a tool to actually do it properly, I can't not, right? Like, I have to use my... I have to use our toys. Okay, so let's... I'm still getting used to this thing. Alrighty, let's add in our screws. Okay, so we're going to need 3... Alright, so let me gather up our parts. We're going to make 3 holes. Okay. Is this a screw we're going to use? We're going to need 3 holes. One for the socket, one for the screw head, one for the shaft of the screw that doesn't make contact, and one for the heat set insert. So let's do so. I think we're going to use countersunk screws. So let me think. Do we want to use countersunk screws, or do we want to use countersunk? We use cap head, or we could just use socket head and have them sticking out. I think we should use countersunk. So yeah, I've got a whole bunch of them here. Allergies. I took a Claritin and everything. This sucks. All right, so we've got our screw right here. We'll pull the dimensions from that. And we got some threaded inserts. And I think this is an M3 screw, and we are running rather low on M3 inserts. We only have the wimpy ones. That's fine. This thing shouldn't have a lot of. This thing shouldn't have a lot of punish. Shouldn't be taking a lot of punishment. Ultimately, you know what? Let's change our size here. We're going to switch down to. We're going to switch down to 2.5 millimeter because I have a lot more high quality inserts for 2.5 millimeter. This is welcome to the design process. Yeah, check this out. So you can see these are much longer. The 3 millimeter heat set inserts that I have left are they're the kind designed to be swaged in. They're not really heat set inserts. They're just inserts. but this is the one we should use. Okay, so let's model this thing. So the top of our screw is about 5. I'm going to make this. I'm going to add a little more leeway so that it countersinks a bit further. So we're going to call this 5.5. Yeah, let's call this 5.5. We only need to do this once, so don't worry. Why did that happen? We don't want this to be construction. We'll call this 5.5. Let's zoom in. Alright, so this is an M2.5 screw, so the hole should be about 3 millimeters, give or take. Yeah, let's call it 3. And the heat set insert, the part you want to measure on a heat set insert is the little bit on the bottom that helps to seat it. And we want ours to be just a little bit wider. So this is measuring 3.7. So we're going to make our hole 4 millimeters. All right. So that's that. All right. So we want to. All right. So in order to do this quickly, I'm just thinking the best way to do this. The best way to do this is probably to mirror that'll take a lot of time. Alright, so we're going to copy these and we'll mirror them across this line. Very nice. And then we'll mirror again. We'll mirror our original and the one we just mirrored. And I don't have another line for that, I just realized. Yeah, let's see. Where can I draw this? So we'll draw a construction line between here and here. Then we'll draw another construction line that is... so you draw another construction line that's... Still having a lot of trouble with this thing. Alright, that's parallel, and we'll midpoint both of these, and now we should be able... to do this mirror properly. So let's select... Helps if we actually select the mirror tool, doesn't it? So let's select our 1, 2, 3, and then our clone 1, 2, 3. Alright. Why are there 7 objects selected? We don't want 7, we want 6. Alright, mirror line is right here. And it seems like we selected too many items. Let's not think too hard about this. Okay, so awesome. And alright, next thing I just want to check is that there's enough clearance. There's enough clearance that like it'll be able to bite in well. So we're just going to open up our inspect tool and check the dimensions between that. 2.5 millimeters, more than enough. I think this is perfect. Next thing to think about is how we intend to attach. This to the. Pardon me. How we intend to attach this to the extrusion, and for that we're going to want some holes that fit a 4 or 6 millimeter screw. So yeah, let's go ahead and grab a couple of those. So these are the little T-nuts that. All right, let's see. These are little T-nuts that slot into the extrusion. This is where we're going to mount it. So this is where we're designing around, and these little T-nuts go into the extrusion like so. Well, they're not supposed to do that, but they're supposed to turn sideways and lock themselves in place. So we don't need to model those, but we do need to use a screw that will fit them. And the ones I have are, I believe, 6 millimeters. So it's a good thing I organized all this stuff. All right, we got our big hardware box. Is it in there? I don't think so. We're going to put them here. All right. So here are our 6 millimeter. Are these 6 millimeter or are these 4 millimeter? M4. Let's see. These are M5. Oh, how fancy. These are not the screws we want. No. I bought a whole bunch of these things, so everybody 1 sec, we're going to hunt them down. They're There are only so many places these things could be lurking. So I don't know why I'm having so much trouble finding them. Shouldn't be in here. Small hardware, American hardware, wing nuts, washers. Alright, there we go. Folks who buy a lot of, folks who try to keep your workshops stocked. I think these ones these could be the ones to use. We've got these 5mm and we've got 6mm. Let's do 6. Folks who keep your workshop stocked up with like small hardware, how do you pick which sizes you get? Do you just like get every size of like M2, M3, M4, or are you more selective in picking? Are you more selective in picking them? Like, how do you organize them? Because last thing I want to do is like set up a big wall with like sizes, and then I'm like, oh, I now have 32mm M2.5 screws. I guess I have to move everything down. All right, let's do some more design before we lose all of our viewers and everyone starts hating us. Oh, by the way, today's stream is sponsored by Things. Thanks a lot to Things for sponsoring this show and making it possible for us to make all kinds of cool stuff. Things is your source for all kinds of 3D printable items, whether you want to share your projects or you want to find other people's projects, or you just want to search across the web you just want to see what's out there. Use the link in the description, go to things.com, use their augmented reality tool to visualize it in real life. And enjoy. Enjoy all of my projects from all of my videos. Most of my projects are on things.com. So use the link in the description and check that thing out. Roscoe is barking and he never barks, so I'm sure something is going terribly wrong. All right, let's add in these screws. Yes. So let's rotate this. Let's rotate this because this is the. Let me think here. Rotate this because this is the orientation we're going to be working on this. We're going to lead the HDMI and other cables down to the bottom of the printer and around the back on the outside, because for now I don't want to drill any extra holes. So it looks like a lot of folks are sticking to M3 and M4, buying a lot of sizes of those, and then getting other screws as they need them, which I think is a pretty smart way to do it. Maybe that's what I'll end up doing. I'm partial towards M2.5 myself, but not for any good reason. So, all right, we already have a center line that we modeled in before. So, question is, how far apart? How far apart are these? So let's see. We're going to measure this. This is 22mm, and we're going to measure this. That is 8mm, and we're going to add those together. So that's around 32mm apart. We want these about 32mm apart. So let's do so. All right, we want construction lines going from let's stick to the inside of the display. Yeah, let's get a construction line going from. You'll see how I'm going to pick this. So, all right, we've got a construction line there. We want to mirror the construction line. It's already picked an appropriate center line. Very nice. All right, we figured out that these are 30mm apart. Okay, so when looking at this, where did I put it? Here we are. So, right, when looking at this, this part here, let's see. So these lines here designate where electronic components are. Now, my original thought was try to put these screws somewhere that they're not at risk of colliding with any with any electronic components, but it looks like that's not going to happen. So we'll put one of ours right here where it's not at risk of colliding with anything, and we'll just put the other one here and hope for the best. There aren't a lot of. So this part here, even if it collides with something and blows it out, that's the sound section. That's the audio amp and stuff, and we're not using that. So it's fine. We can destroy stuff. I'm going to pull the HDMI cable out because it's already served its purpose, and it'll make it a lot easier to handle this. So there we go. All right, so let's put this here. So we don't want this to be. Oh, all right. So the cap of this screw is about. Let's see. The cap of the screw is in the neighborhood of 11. Let's call it 11 millimeters. Close enough. Yeah, 11 millimeters, and let's see. The shaft of the screw. I mean, this is an M6 screw, so it's going to be 6 millimeters. So let's about 6 millimeters. So let's call it 6.5. We're gonna call it 6.5 because we want a little bit of wiggle room to help us position, to help us line the nuts up within the slot. So let's call this 6.5. 6.5. All right. We don't need a mating end to this because the nut is taking care of that. The nut. All right. How far do we want this? This can be arbitrary. Let's just call this 16. Okay. Cool. So, yeah, to make this symmetrical, we'll just let's see. No, we don't want this mirrored. We want a circular pattern to make this symmetrical. So select the stuff. Why is it selecting the wrong thing? Changing the display density has been having some very strange effects. Looks like we actually need to designate the point ourselves. There we go. All right, so let's do a circular pattern. Picking these two objects. Our center point is this, and we want 2 of them. And cool. Okay, so this is going to work. It's going to collide with the HDMI port. So let's just make this one a little bigger. Can we move this out of the way? 22. Can we go further? 24, 25? There we go. Perfect. Jose Acosta, thank you so much for the super chat. Side note, my cheap digital caliper is giving me issues. What would you recommend? I got this pretty fancy Mitutoyo caliper, and I love it. This is a great caliper. A caliper is one of those things where if you do a lot of 3D modeling, you are going to use it all the time, constantly, for everything. So, yeah. Yeah, you're going to be using this for everything, so it's worth spending a little more on. It looks like I missed a super chat. I am very sorry, Akalia. Thank you so much for the very generous super chat. Yee, new 3D printer. USPS just delivered my Ender 6 and the Hemera upgrade. I'm really impressed with the Hemera. The filament path is really short, and it's intrinsically all metal, and I'm really impressed by it. Also, the same extruder, you can make it either using the same parts, same kit. You can either make it direct drive or Bowden, and I think that's really cool. I like it a lot. Yeah, you gotta get the Mitutoyo. I'm thoroughly satisfied with them. So with this, I believe we have everything we need. Yeah, I believe this is everything we need to actually perform our model here. So we're going to finish our sketch. We're going to save our work, and let's take a look at how I dimension this for the Data Blaster. Luckily I can just copy my my dimensions down. So right, it looks like for the rim we gave ourselves 1.2 millimeters. That's about flush, I think. We could make it go in a little bit deeper if we want. I don't think it's strictly going to be necessary. So yeah, let's begin by performing an extrude on. Let's see. So we're going to want to extrude everything that's not going to have a display over it. Here we go. By 1.2. Very cool. Okay, so then we've got this bit here. This is the amount of CoreXY has given me a few quid. It's not pronounced Hemera. It's pronounced Hemera as in hedge. Hemera? I've heard it was pronounced Hemera, and I, in fact, have had a couple people tell me that the H is silent, so it's Hemera. So who knows? Hemera. I will just call it we should just call it like hemorrhage instead. Reagan, thanks a lot for the super chat. For prototyping, I use 2 millimeters for fiddly bit, 4 millimeters for workhorse, 6 for hinges. Keep it minimum tools a project and even numbers. Me? I typically use M2.5. That's sort of where I start, and I'll change that up from there. But now that I have finished building this guy, I have a lot of M3 hardware, so I might actually switch to M3. It's also a lot easier to find M3 stuff like sockets and whatnot. So yeah, I don't know. I think I'm going to switch to whole numbers. I think I'll go down to M2 for small things and M3 for bigger things. I don't usually make things large enough to use an M6 or something, but who knows? Okay, all right. So I made this 7.5 millimeters, but I think it's actually a little low. I think it's actually a little narrow. I'm going to make this one a little bit deeper. Hang on a second. I'm going to make this one a little bit shallower because I think on the Data Blaster, the frame is putting pressure on. The frame's putting pressure on the USB or on the cables, or maybe it's the cable itself that's the problem. So the actual dimension here is. Wait a second. I'm mixing a couple things up here. I think. Yeah. So let's see. To bring it. Yeah. So the dimension I'm looking for is not that one. It's between this and the. Between this and this. That's still 7.5 millimeters. So where am I getting that? That seems off. So we've got 1.2 millimeters, and then we've got. So where'd that 7.5 come from? This is why I'm working off known good dimensions instead of like eyeballing it myself, because I don't actually know where that ended up. So it looks like. Yeah, so it looks like that's the dimension between the backside of the touchscreen and the top of the circuit board without any of the components on it. So I think that dimension was good. We're gonna keep that one. Yeah, and our support is going to be. This is where things get a little tricky. All right. So then, the rim, I just realized that the rim is not going around the entire thing. Is that going to be a problem? I don't think so. Jeff says, geez, just Control-C and Control-V. We can't just copy and paste. The makeup of these projects are completely different. I know it's not the most pulse-pounding, I know it's not the most pulse-pounding thing around, but, So we need a surface for this to glue onto. Is that what this is? Yeah. So we're gonna need a surface for this to glue onto. So let's pick this stuff right here. And we're also gonna pick everything we just extruded. I know it's not the most exciting, but this is what an unvarnished look at the prototyping process looks like. I feel like I've been glossing over stuff a little aggressively lately. So So we're going to start from the geometry that we just. Thing is flying all over the place. Yeah, so we're going to start from the geometry that we just made, and we're going to let's just call it 1.2 minus 1.2. All right, and that'll give us a lip to attach to use the double stick tape on this to mount it. So this is going to be like a sort of bezel-less, right? It's going to go right to the edge. I think that's going to look pretty cool. So let's. Next thing to do is to add in our support for the circuit board. Let's see. Or is this supposed to be our? Yeah, I think this is supposed to be our 7.5 minus 7. Oh, minus 7.5. All right. Yeah. So this brings us down to the edge of the circuit board. Reagan says this is the worst cell phone I've ever seen outside the Sidekick 2. With friends like these, who needs enemas? All right. So we'll go back and add in. We're going to go back and add in more relief for the HDMI and USB cables. We'll do that later. for now, let's finish our design. So then, all right. After that, we added a bit of relief for the components on the circuit board. That looks like it's 2 millimeters. So that's what we're going to be working on next. All right. So we're gonna E for extrude, and for this we're gonna want everything that doesn't have components on it. So yeah, don't think too hard about the holes. We're going to be adding we're gonna be adding those later. And I realize I now have to go back and change some of the other. I gotta go back and change some of the other stuff because we're gonna be adding in the holes later. All right, this is. Yeah, the different display density is making it a little challenging to click stuff, but hopefully it's making it up to you folks by making it easier. Hopefully it's making it up to you folks, making it easier for you to see the text. If you can't see the text, then we'll either drop the density or go in the other direction. All right, so we'll add our cutouts later. I think that's the way to go. It's always tricky to. Let's see. Yep. Just comparing the two. It is always tricky to talk and model at the same time. Yeah. So we'll start from an object, and the object is the surface we just created, and we're going to continue down for, no, not 0.2, for 2, minus 2 millimeters. I'm just going to go back here, and we're also going to extrude. We're also going to extrude the holes. We'll cut those out later because I don't actually know where they're going to fall in between the two pieces. So, yeah. The question is, should that part we just did be, Yeah, we're going to need to slice. We'll slice this somewhere. Slice this somewhere in the middle. We'll slice this after the fact because yeah, we can't build this in one piece because then once we glue the display in place, we'll never be able to remove the assembly from the extrusion, and I am going to make some mistakes, and we're going to need to do that. So yeah, and then finally, okay, good. All right, so. This brings us, all right, so this brings us down to the, let's see, yeah, all right, so this gives us everything we need to support the main board. We now need to continue on for the HDMI and stuff. So we're only going to be modeling this on the board itself. Let's see. So so that's this cutout here. So we're only going to be modeling this part on the board itself. We're going to cut out what we need for the HDMI cable and stuff afterwards. So let's continue. Let's take a look. So where's our HDMI? Where does our HDMI end up? Or have we already taken that into account? So 2 millimeters. So let's just double check. I might have already taken this into account. So question is, all right, so from the top of the HDMI port to the back of the touchscreen is in the neighborhood of 13.75 millimeters. So let's see how far we've gone here. So from the back of the touchscreen to the lowest point on our drawing is 7.5. Shouldn't that be deeper? Oh, it should be the bottom. So that's 9.5. So we do need to make, let's see. So yeah, we do need to add a little more to this to bring ourselves to the bottom of the HDMI. Alrighty. So then for this we want to extrude literally everything except this one square right here. Cool. So let's. There's so much to select. I probably should have mirrored the features for the screws instead of mirroring the holes themselves, because this gives us more things to click, but it would take more time to correct it than it would to just brute force our way through it. So let's do that. All right. Okay, so here's what we're going to do. We're going to start from the lowest point on our geometry, and or actually, hang on a second. We're going to start from wait a sec. Where is this? So our drawing is in the bottom of. So our drawing is done from the bottom of the touchscreen. So we actually want to start from an offset plane. All right, and the offset plane is going to be our dimension that we were talking about before. I think it was, yeah, let's call it around 14. So we're going to start from an offset plane of minus 14, and we're going to continue this to the object, or to here. What's going on here? Yeah, so that should do the job. All right, let's save before anything else goes wrong. And let's just do a quick sanity check. From this to this should be 14 millimeters, and it sure is. I made a boo-boo. I extruded this to the wrong place. Haha. Alright, so we're going to extrude this to an object, and the object that we're extruding to is there? Wait. Offset plane, extent to object. I'm confused. What's going on here? Why is it extruding too far? Oh, it's not. Never mind. It was just my sketch was confusing me. All right. So this brings us to. All right. So we should now be able to just plop this thing in and it'll work. Next things we have to do are add our cutouts for the USB cables and for the USB and the HDMI cables. And for our screws. So this is where we need to hunt around on our floor for the HDMI cable wherever I threw it. All right. So yeah, let me. So I think we're done with this. Actually, now we're probably gonna have to extrude this a little further. Yeah. If you we're gonna. All right. I'm a little scatterbrained right now. It's very hard to look. It's very hard to talk and it's very hard to talk and model at the same time. Something about 3D modeling just like uses my entire brain. So all right, first thing we're going to do is model the screws cap, and for this we're just going to do an extrusion. And we're going to taper it to give us the countersink in one quick and dirty, in one quick and dirty step. Let's see if I missed anything from Brooke. Nope, doesn't look like it. Very nice. All right, so let's model this. So the cap of the screw is about 2. Let's call it 2 millimeters. It's somewhere. It's give or take 2 millimeters. So, yeah. So we've selected these. We're going to start from the profile plane. We're going to extrude down 2 millimeters. Very nice. And our taper angle is give or take 45. Oh, wait. No, we don't want to start from there, actually. We want to start from our highest surface. There we go. Okay, good. We got some countersinking going on here. Next thing we want to do is we want to extrude our. Yeah, there we go. We want to extrude the shaft of the screw. The shaft. No, we don't want to extrude that yet. We don't want to extrude the heat set insert quite yet, and we want to punch through the entire thing. Or do we want to do this later? Let's do this now, and then we'll just back up. So we're going to do this symmetrical, and we're going to punch through everything, taper angle of 0, both directions. Very nice. All right, so we're actually going to roll back because I realized that we're going to have to bulk the back of this up a little bit so we can give ourselves more room for the screw. So yeah, we need to give ourselves a little more room for the screw, and we're going to want our, actually, I think I'm overthinking this. It doesn't need to go in that far. Yeah, so let's see. We have, all right. So we've got our, oh crap. Luckily I saw it. All right, we got our screw. We got our heat set. let's thread them in and figure out where exactly we want to place our heat set. Okay, so we've threaded it in. Here we go. Looks like we want to leave. Let's call it 3 millimeters. Oh, 3 millimeters of clearance. Okay, so we don't want to punch. So like, all right, we don't want this to punch all the way down. Let's just call it. Let's call it 10. Let's just call it 10 millimeters. Not through all. We're going to go distance minus 10 millimeters. Very nice. Alrighty. Next step is the heat set inserts. So let's select our heat set insert geometry. You notice I'm holding Control. That Control will cause. So once we've selected one profile, Control will cause all of our selections to only target profiles, which speeds this up rather a lot. All right. So we want this to go on one side. We're going to start from. All right. So we're going to start from the. Let's see. I want to start from the point where we just. I want to start from the bottom of the countersunk. Let's see. I want to start from the bottom of the countersunk screw that we just modeled. So let's see. Wow, I'm having so much trouble with this. I should be selecting the vertex. Why am I having so much trouble with this? So whatever this is, we're going to start from 3 millimeters below it. But I should be, but like, I don't know why I'm having so much trouble selecting the bottom of this this countersunk bit. Huh. Let's just then we'll just use the same dimensions. So we're going to start from. All right, so our object, we're going to do this. So we're going to start it from minus 2 millimeters to bring us to the bottom of the screw head, minus 3 millimeters to give ourselves a little wiggle room. And the length of our heat set insert is it's 5, but let's just call this 6, because some of the plastic that we push out of the way as we insert it is going to pile up at the bottom. So you can never insert a heat set insert all the way. So yeah, let's just switch over to section plane. Let's make ourselves a section plane. Just make sure this looks reasonable. Yep, this looks fine. So we've got our countersunk head. We've got the shaft of the screw, and then we've got a generous area for the heat set insert. Very, very nice. Cool. And looks like we've got that in all the positions. All right. So next thing we got to do is we have to give ourselves a little more room for, a little more room for our T-nut. So let's figure out how much room exactly we need. All right. So when this is bottomed out on the T-nut, we have we have about 3 millimeters again. All right. So we're going to need to leave 3 millimeters of space plus a further, let's call it 4 millimeters for the head of the screw itself. And looks like, so the lowest part, all right, so this bottom part here is 4.5 millimeters. So we have a little bit of wiggle room. So we need to give ourselves 6 millimeters. Stand by one sec. All right, so we planned out 7 millimeters, and let's give ourselves 2 millimeters from the bottom. So we need 5 millimeters of space. Cool. So I'm just going to hide the body, just like my average Friday night. Right, we're going to extrude everything. Yep, from there. All right, so we're going to start from the bottom. All right, so we're going to start from here. No offset, and we're going to give ourselves, we decided 5 millimeters. All right, so this is going to stick out a little bit. That should be fine, but let me just quickly confirm that this will actually fit. So this is saying it's 33.5 millimeters. So I'm going to set my caliper to 34 millimeters, give ourselves a little wiggle room, and just make sure that this completely fits. Wait, that can't be right. It's 83.5. Yeah, that makes a lot more sense, doesn't it? Hang on a sec. That's too much. This thing isn't 83 millimeters wide. This is 76 millimeters wide. What the heck? Are these... The two can't be different sizes. 83 millimeters for... Something funny... Hang on a second. Something funny is going on here. I'm going to go back to the Data Blaster and take a look. What's going on here? From here to here... Fusion 360 is encountering slow performance. Oh my. That sounds like a them kind of problem. Let's investigate this. So from here to here is 77.5. So how did that become... So that's correct. How did that become 80? What is going on here? 77... this has a rim around it. I just didn't extrude it. All right. Okay. All right. Let's set this thing to what did we say before? It was like 84, and let's just make sure it fits. Don't trust anything, especially not yourself. All right. So it looks like the way we have this lined up, it would. Here, let me show you. Why isn't this... What's going on here? Why isn't our why isn't the pad working? All right. Yeah. So as it stands, this wouldn't fit. This would be too wide. So I'm dumb. That's the first takeaway from this. That's the first takeaway. And the second is that we want to shift this. We want to shift this over. Yeah. So we want to offset our mounting holes such that let's see. We want to offset our mounting holes such that the edge has a millimeter of relief. So ballparking this. Right, we want this to be... Alright, so we want the right side hole to be about 14, 15 millimeters from the edge, give or take. So why is my trackpad not working or why is my stream controller not working all of a sudden? I think it crashed. What the heck is going on here? Why is... Something funny is going on. Stream controller is not behaving. Poop. Okay. All right. So, all right. Problem identified. Yeah. So let's get rid of this the symmetrical constraint wherever it is. Where's our symmetrical constraint? The one that makes the symmetrical constraint that makes these lines symmetrical about this center line. So we want to get rid of those. Right? And we should be able to move this around. Why can't we? Alright, let's make this thing vertical. Alright, good. Good. So, we want, wait a second. Why is our symmetrical? Oh, yeah, we're rotating around a symmetrical constraint. Okay. Let's delete this. And, alright. Let's manually adjust this. I'll put these concentric. This is just a normal part of the process. Sometimes you have to redo some of your geometry as things change. Sometimes you bake assumptions in, right? You bake assumptions into your initial design that don't end up bearing out, and that's exactly what happened here. So let's make this 13 millimeters apart. Let's try 14, just so it doesn't overlap as much, and we'll see what happens. So yeah. So if this is 14, millimeters apart, then actually I think it's going to overlap a little bit. Let's cut this down. This is going to hang off the side, so we'll just have to remember to round part of the back. Yeah, it's part of the process. At least we picked this up before we dumped a few hours into printing. Right. Yeah, these were previously a pattern, and now they're not. Alrighty. So this top part here, we forgot to add in these dimensions, or we forgot to extrude these elements. So there we go. That looks a lot more. That looks a lot more reasonable. Alrighty. So this. Why wasn't this working? Let's take a look at our warning. Body reference is lost. Reselect it. What? Nothing seems to be lost. Yeah, nothing seems to be lost at all. This looks fine. Everything's fine. Everything is fine. Alrighty. So, yeah. Okay. Alright. This makes more sense. So you can see we've shifted the holes over. So, yeah, we've shifted over the holes, which should now let this thing hang off the side so we can open the door without, having a display in the way. Excellent. Alright, so let's measure this. So let's model this thing. So first we're going to start with the cap of the screw. Alright, cap of the screw, including all of these. We're going to start from, let's see, we're going to start from here, and we decided to leave 2 millimeters, right? So we're going to offset this by 2, and this is going to punch through the entire rest of the drawing so that we can access our screws. So let's flip that around. Very nice. All right, so I think we might have made a minor boo-boo. Let's just verify that we have enough clearance between these. It's 2.5 millimeters. The head of the screw is about 4 millimeters. So our dimensions are a little off. Let's see. So we're starting from there. But I'm confused. I thought that was correct, but I guess not. So let's just cut the offset. Yep, there we go. Cut the offset. Beautiful. Perfect. A-okay. Excellent. And yeah. So yeah, we punched that through, and now the hole for the shaft of the screw just goes straight through, and we'll adjust things so that is also the correct dimensions. So let's extrude this and this. Extrude this. We're going to start from an object, and the object is going to be the base of the screw. No. Yeah, there we go. Going to be base of the screw, and we're going to go through everything. Everything. All right. So let's see. Distance between here. Let's hide our sketch so we can select things more easily. Between here and here is 5 millimeters, and that shouldn't be 5. That should be 2 or it should be 3. Let's call it 3. Froze for a second, gave me the heebie-jeebies, so let's save. So let's just make sure, these are 5 millimeters apart, so they're not going to collide. So this part here, we extended this. All right, so we extruded this to be 2 millimeters too deep. How did I mess that up? All right, cool. What's our warning here? That's weird. Our warning seems to be nothing. All right, so this is it. Only thing left to do is we have to model in cutouts for the HDMI cables. So yeah, let's grab our thing. We're gonna want to model this one on the side. Yeah, there we go. Yep, and let's, there we go. All right, so these are the, did we set up this drawing on the wrong plane? I think we did. It should be here. All right, so let's create a sketch on this here face. I don't know what, like, that's really weird. Okay, so let's project. All right, so let's project the dimensions that we, or let's project the spot we already did for the HDMI cable and the USB cable. Right, we'll project that on, and where are we going to start this thing? We're going to project. So this right here is the top. So this bit right here, this geometry, is the top of the USB or the HDMI socket. So let's project that too, and we're also going to want to probably project the surface that we're on. All right. So this should give us all the information we need. So yeah. So we got our USB. Are we? Yeah. All right. So this thing extends about. So this thing extends somewhere in the neighborhood of let's call it 2 millimeters, 3. Call it 3. All right. So we're going to offset this line by 3. Is that right? Did we just not leave enough? Not leave enough room here? Or is this going right to the back? I guess it's going right to the back. So then let's not. We won't even worry about this. Let's just bring this all the way off the top of the earth. All right. So from the back of the. All right. So from the back of the touch screen to the bottom of the HDMI cable. It's neighborhood of 5 millimeters. Let's call that 5 millimeters. All right. So basically, this is going to be our cutout. This is going to be collinear, or this is going to be coincident with this. These are going to be 5 millimeters apart. We're going to bring this all the way over to the HDMI cable over here. So this is going to be collinear with this, and let's see. Let's hide that, and then this needs to be brought all the way. This. Oh, there's no special cutout for this because the micro USB port's only like 2 millimeters tall in the first place. Cool. So this needs to be extruded all the way. No, not all. I said all, but I didn't mean it. Right to here. Okay. There we go. So this is going to be the cutout on the back, and that is our model. So let's hide this as well. All right, this is it. This part is ready for testing. Yeah, this part's done. It's ready for testing. Only thing left to do is we need to split it into 2 parts so I can take the display off and access it. So that has to be in between, so that has to be somewhere along this mounting screw or at the bottom of the mounting screw because that's the only place we can. Let's do it at the bottom. Or let's do it there. So here's how we're going to do this. We're going to construct an offset plane using the top of the heat set insert as our plane. And then we're just going to split. Where's our split? We're going to split the body. A lot of things to be taken the wrong way out of context here. And there we go. We now have 2 parts, a top plate and a bottom plate. Yep, we now have a bottom plate that's going to get attached to. Bottom plate's going to get attached to the thing. And then we're going to put the thing in there. Then we're going to screw the thing on top. Radical. So let's see. Just some little bits of cleanup. Then I'm going to. So corners like to curl, right? Corners love curling, but rounded edges they don't curl very much. Yes, split that body. I can always trust all of you to be a bunch of pervs. Yeah, and I think I'm going to chamfer the bottom. Actually, no, we don't want to chamfer because then it's going to have an overhang. But let's just. All right, we're gonna undo. I'm just going to round the bottom so it looks a little nicer, and so I don't scratch myself if I like bump up against it. Like if I mess up and bash my something or other into it while walking past the printer. It'll also make it look a little more. Also make it look a little slimmer. All right, so now we do the chamfer. 5. All right, that looks good. So obvious thing to do here is to try to print this. I think 5mm is too aggressive. Obvious thing to do is to try to print this on the Toolchanger itself. If we want to make the color consistent, then we are going to need to print. Let's see. Then we're going to need to load some PETG. We're going to need to pull that out of the Prusa, and we're going to load it in here. What do you say? What do you think? Is that our play, or should we run it off in the other room and do something else, like try to wrestle with a multi-material print here? Any preferences, folks? Yeah. By the way, you can stop leaving. 3D modeling is done for now. We're ready to print. David says I have a small overhang in the USB port. I guess there's a bit of a. I guess this is an overhang. This is a bridge. Yeah, I guess there's no reason not to just extrude this. Let's hide this. Yeah, we can just carve that out. No reason not to. That way we don't have to print with any support material. A problem prevented is better than solved. Wee! 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 Yay! Alright, let's print on the Toolchanger. Let's print on the Toolchanger. Something has gone totally wrong with my Stream Deck. And I don't know what it is. Now it seems to be acting like arrow keys. Is it possible I hit numlock somewhere along the way? Is there... Maybe did I accidentally hit a numlock? Is that possible? This keyboard doesn't have numlock, so I don't know. Let's just search for an on-screen keyboard and see if there's a numlock soft key that I can press. On-screen keyboard. Print screen, pause, scroll lock. Scroll lock? Is that it? No. It must be the Amogus key. I mean, it has to be, right? Like, what other options are there? Let's just get this back. Like, what other options could there be? And it has to be the Amogus key, right? How do I turn on numeric keypad? Numlock. Oh, there we go. That's it. That's exactly what the problem was. Numlock got turned off somehow. That's really weird. Yeah, it must be the Amogus key. What do you think? Should we throw the imposter out the airlock? Yeah. Oh, am I better? Am I better? I think I... Oh, what happened? What happened? What'd I do? That sus key, it got me on the way out. It seems as though, yeah, there we go. Okay, awesome. No, we don't want this to be 2300 degrees. That would explode. All right, so bear with me one sec. I'm just going to move the. I'm just going to raise the camera a bit so we can see what's going on among us. Here's a question for the smart people in the audience. Do we need to put anything on the bed? I haven't printed PETG. I haven't printed PETG on bare glass in a very, very long time. Are we going to need some glue stick or something? Let me know in the chat, because I sincerely don't know. Let's see. Yeah, that's good enough. All right. Well, we're not going to be doing any filament changing unless we pick the tool up first. So let's go ahead and do that. Pick up tool number 2. There we go. Looks like we're going to need the glues tick. Alrighty. So then I'm just going to... Oh, wait, we made a boo-boo. I hit a home button while we had something attached. Uh-oh. I hit a home button while we had a tool engaged. I think everything has gone wrong here. I think we screwed up. Oh, it's preheating first, and then it's gonna. Yes. All right. Looks like we're gonna need glue. PTG does. Yes, that's right. PTG does bond itself to the bed. That is totally correct. So it looks like this thing's coming up to temperature. Actually, homing the y-axis should be safe with the tool equipped. So let's get in here. We're going to need one of these. We're going to need one of these. All right. So this is the filament that we've been printing. This is the filament that we have been printing the rest of the stuff for the Toolchanger on. So that's what we're going to be doing our printing today with. So let's start dressing the bed. Where are we at? We're at 200 Celsius. Yeah, we got to do some PID calibration here. I can't get in there because the friggin' axis is in the way. As soon as this thing, all right. So this thing is here. Let me show you. Yeah. So this thing is going to heat up to 230 Celsius, and then it's going to home the y-axis because I'm stupid. And then I'll be able to apply the glue to the rest of the bed, and at some point we'll be able to load some filament in here. Actually, there's no reason why we can't load the filament now, right? Like it's gonna take some. Oh, there we go. All right, so now that that's out of the way, let us glue. Slather it on. Lots of slathering going on here. All right, very nice. Maybe we should have run this off with the Volcano, but then I'd have to adjust the tool diameter and a whole bunch of crap. Okay, so glue is applied. Let's feed the filament in through this very, very long guide tube. This thing is a real long boy. Come on, let's see if it gets through the coupler that I printed. It's not. Oh, there it is. Made it through. There's some friction in there, though. Yikes. Actually, no, the friction's happening somewhere else. Not that it makes it any better, but okay. Filament's going over the cable group. There's a lot of friction in here. All right, it's going into the extruder. I'm going to pull out the guide tube so that we can load it by hand. Let's see. Does this help at all? I think. Yeah, this it's making a pretty aggressive turn here. And there's no real way to prevent that, is there? Let's see. Yeah, this is going to take some work to pull this filament through. We might have some feeding problems. The other one wasn't as bad. I'm going to open up the coupler, see if that has any effect. Not really. Well, let's see how this plays out. Don't worry, we'll be out of this in a sec. All right, perch that in place, and we should be able to just click load filament, and should work. Oh, we don't have any filament presets, so I have to do this by hand. All right, so many gotchas here. There's a chance we plug this in backwards, and it won't engage. No, it definitely caught it. It definitely engaged. Let's feed a bunch more filament in. Oh, it's happening. It's happening. Oh, there we go. There we go. Oh boy, oh boy, oh boy. There we go. It's pooping out a little bit of filament. There we go. All right, we have PETG locked and loaded. So, yeah, we have PETG locked and loaded. PETG, we don't need to use the enclosure to print here. Honestly, I don't think it matters one way or the other, so we'll leave it open. But yeah, so we'll leave it open. But let's make this. Yeah, here we go. All right, so for this, I'm just going to save the STL file in our downloads folder, and we'll take it from there. Control panel top. Let's open up. Where's Super Slice? Here it is. Super Slicer. More like Sus Slicer, am I right? Back over here. Let's get that sus key out of here. And let's see. Let's grab our STL that we just made. Doesn't look like, yep, no supports. We're in business. I am going to use a brim because it's very thin, and that has a chance to pull off. We changed the layer height. I'm going to, there we go. Yeah, let's change this to 0.2. Maybe 0.25 would be better, actually. All right, so this will take an hour and some change. That's fine. Only other thing we want to do is, let's see, we want to change this to print with extruder 3. G-code extruder 3. Okay, cool. Yep. This was actually, this profile was derived from the assemble demo. We'll talk about assemble in a bit. Yeah. 0.3 layer. I don't like printing 0.3 layer height with a 0.4 nozzle. I think this is a good start. I think it's a good starting point. All right. So there shouldn't be any other funny stuff because this is otherwise the same profile. This Eris Palm Ash. What speed and acceleration are you using? Here, allow me to show you. I've slowed this down a lot. I've slowed this down to about, it's printing slightly slower than a Prusa, because the printer's still not, I'm not totally confident in it. Let's just say. So we're not going to push it to the limit just quite yet. All in time. So let's hit upload, let's pick our G-code, and let's friggin' pray, right? Alright. Looks like I actually... Oh, wait, hang on a second. I forgot to change the material. I keep forgetting. I forgot to change the material. All right, we're going to cancel that. We got to go back to our filament settings, and we got to change our first layer. We want it 240, and I think other layers we probably want it 230. If we try to, bed probably want like 80 Celsius, 75. Yeah, something in the neighborhood. Filament type. I don't think this makes any difference. I don't actually. I have to set up our filament presets. Let's make sure this is canceling. Oh, we're having all kinds of problems. Oh, it did not like canceling that. Oh, it did not like canceling that. We're gonna rehome the machine. We're gonna reslice for PTG temperatures, and we're gonna take that one from the top. Yeah, you're hearing a lot of noises happening. Yeah, this is why I've been trying to keep everything, slow and easy. Let's frame this back up. There we go. Yeah, let's frame this back up a little bit, and let's upload our revised G code that should go to the right temperature. Let's see, loading properly. Let's see, it's picking up the tool. Very nice. Right, the bed heats up like that. The bed is so powerful. It heats up like crazy. All right. Yeah, I got to adjust the PID curves. These things have socks. They should be heating up real fast. Yeah. All right. Let's hope this is working. I'm seeing a line. It's going off the side of the glue though. I thought I centered this, but maybe I did. I didn't. I thought I centered this, so maybe our Z is humping correctly. What's going on here? Oh no, it's just bigger than I expected. It's just really big. Let's see. Yeah. All right, we're gonna cancel this. I didn't glue. The glue didn't go. I didn't glue all the way to the edges. So let's see. Yeah, canceling a print does all kinds of weird stuff. I don't know why. Rene, if you're still watching, this is a weird issue. Yeah, something about the cancel script just caused it to crash and go crazy. Luckily, it doesn't seem to crash in the Z-axis, so it's unlikely we're going to break the glass. But still, don't worry. Don't worry. If we break the glass, it should only take a day or two to get a replacement. And I've already got a bunch of the Z-axis homing switches, which like to get snapped off when you make a boo-boo. I have 5 of those coming in from DigiKey that should be here any day. So yeah, gotta be bold. Gotta be bold if you're in this hobby. All right, we've homed again, so let's start this one from the top. Maybe we should snoop around the scripts and figure out exactly what it's running when we cancel a job. Oh no, Rene had to go to work. Aw, come on. Yeah, the cancel script is a mess. I've adjusted most of the other scripts, but let's see. So while this is heating up, let's take a quick look at our script, cancel.g. Yeah, parking the tool should be this should be fine. Parking the tools, we do that all the time. We've done that like 5 times this stream. And I got rid of the purge, so I don't actually know what's happening here. Yeah, maybe like it's in like different coordinates or something. Like maybe it needs to return like switch back to relative coordinates or something. But yeah, who knows? All right, how are we doing here? We might be leveled a little low. It looks like what's going on here. We're leveled a tiny bit low, so we're going to baby step this back. PETG prints at a PETG. You want a little more headroom than PLA. Where's our baby step control? Here we go. All right, so let's baby step it up a little bit. There we go. That looks great. Looks okay. Okay, so this is going to take around an hour and some change. So yeah, no, I think this is going fine. Yeah, I'll do all my troubleshooting and stuff after the fact. I think this print is going great. We'll see how our first layer looks in a few minutes. Yeah. In the meantime, let me show you exactly what we're building here. Unless you folks want to stay entranced by the printer. Any preference? You want to keep looking at the printer? Should we move on? Oh, there seems to be a little booger on the plate. Let's get that off of there. There we go. Don't want to run over the booger. There, let me show you what's. Oh, all right. Everyone wants to watch the printer. Let's get entranced by the printer. This is your 3D printer ASMR. Would have a printer cam in the corner. I guess we could do that. Yeah, no reason not to. All right, let's switch to our overhead cam, and I am just going to add. Where is it? Right here. We're going to add a video capture device. A printer cam. There we go. And now we can watch everything go wrong. Excellent. Alrighty, let's rearrange the furniture. I'll show you what we're actually doing here. So I programmed this ahead of time, so we all know it's not going to work and it's going to fail catastrophically. So let's watch that. Let's watch that play out. Let's get these screws out of here to minimize our chance of shorts. Let's get this guy centered. I wrote my password on that tape. You don't get to look at it. All right. So yeah, this is actually a really. Oh yeah, there are a ton. I got five. I mean, there are four Hemeras. So I ended up with a bunch of stickers. I think I might sticker bomb the side of the printer because I think it would look cool. So yeah, this is a really cool display because it comes. It basically just like. It comes like. It's a really elegant package. It's very small. And all you need to do is plug in HDMI and USB. And the USB both powers the monitor and it feeds the touchscreen. And it connects it to the touchscreen. So this thing is, in theory, super easy to connect to a Raspberry Pi. In practice, it won't display anything right out of the box because it has this really irregular resolution. The Raspberry Pi won't set automatically, so you have to go in and program a custom resolution. So it's not fun to watch someone set this device up. Looks like we're having some focus problems again, so let's stop that before it becomes too annoying. And let's also try not to reflect the fan. All right, so I've got this hooked up to a Raspberry Pi 2. I have this hooked up to a Raspberry Pi 3. And yeah, without further ado, let's plug that bastard in and see what happens. Let's see, Pi is on. You'll notice the display takes a little bit of time itself to turn on. But it should. Yep, there it is. Looks like you see we don't have enough power. I'm going to actually turn this sideways. Here it is. Look at that weird resolution. There we go. Let's get that out of here. And it's automatically starting up Chromium, and it's loading our control panel. So we should be able to see what that looks like. Looks like the skirt went down all right. Still seems... you know what? I'm gonna drop it back down. I'm gonna drop the baby stepping. Yeah, the bed is still. Yeah, the bed is a little uncalibrated, or the bed is a little not level. Let's say. There we go. So check that out. Yeah, isn't that neat? Wait, why did it stop? Yeah, so there we go. We have ourselves a control panel that we can touch, and since it's since capacitive touch, it's very easy. Yeah, isn't that neat? It does look vaguely phone-like, doesn't it? But it's much taller. Let me prop this up in an angle to get rid of the glare. It does look a little phone-like, but yeah, check it out. It even shows like a little status bar at the bottom. If we go to type in a number, remember before we had that. Yeah, remember before we had that pad? So now we get a little number pad that we can touch, and because it's got that super stretch, it has enough real estate to, enough real estate to make all that work. It's pretty cool. Yeah. So yeah, that's where we're going to. That's what we're going to do. This guy is not 1920 by 480. It's 1280 by 480, which sounds wrong, but it's not. You can get 1920 by 480 versions, but this is the only one I found that has that nice all-in-one construction with the built-in touch screen. No, this is a capacitive screen. There's no stylus to be done here. It might look like it's resistive because it still has the protective film on it. We're going to peel that off very satisfyingly. Once we finish assembling this, because I want to minimize the scratches. This is 1280 by 480. Yeah, so I think it looks pretty good. It's not blurry in real life. I just turned off autofocus because it was being annoying. Yeah. By the way, speaking of, is there a link for the screen? I'd have to go back to the computer to hunt it down. But go on AliExpress and look for Wise Coco. That's Wise COCO. They have a whole line of displays, and this is one of the first ones you'll see because it's just very popular, relatively. Yeah, they have a whole. They specialize in stretch displays, but be careful. Most of them don't have a built-in touchscreen. So yeah, the longness is pretty neat. An interesting property about this particular screen is that 1280 by 480 is just two 640 by 480 screens. So yeah, so two 640 by 480 screens. So like, you can display two VGA things at once. It's very useful. Hawkreek asks, so first time in one of your streams. This is building a Toolchanger for. How am I supposed to answer that? To have a Toolchanger? I don't know. Scott Latine says, I use the panel do with my Toolchanger. It's pretty good. Yeah, but it's $100 and I've already spent enough on this project. And also the UI is different. The panel do UI is much worse than the Duet web interface. Especially if you have multiple extruders. It's really awkward. Yeah, I looked at it, but I decided to just use parts we already had. Waste not, want not. Yeah, you know how it works. They're pretty cool. Unfortunately, I haven't found a domestic supplier of these in the States. So I had to order from China, and it took about 3 weeks to show up, which is why I bought a bunch of them. So if something went wrong, yeah. All right. So technically, there is a specific reason why I'm making this printer, and that is because we're doing another every filament episode. Remember how I said in the last episode that we were printing every filament? Well, that wasn't really accurate. It was just a lot of filaments. This time we're printing every filament. I have a sample of pretty much every printable material I'm aware exists. So, yeah, we're going to print all of them. You want to see some? Like while we're waiting for this thing to print, would you be interested in seeing some funky filaments? I put most of them in back, but I can. But yeah, I have a few lying around. There are some exciting ones. JoeBD99 says, looking forward to the carbon fiber peak. That is one of them. I don't have very much of it, though, so I have to be very careful. Let's look at some fancy filaments. Let me gather up the ones I have lying around out here. My 3D printer closet is so full of filaments. It is downright ridiculous. Okay, so you folks get the idea. So, yeah, basically we're going to be mounting this thing to the frame of the Toolchanger. And, yeah, that's just how we roll. What? Oh, I unplugged the wrong thing.
This one got delivered.
Oh, hey! We just got another delivery.
I wasn't going to bother you with it.
What do we got? Oh, all right. Okay, good. All right. So this box here has like dozens of filament samples that I had shipped in from the UK. But yeah, let's let me shut this thing off and let's take a look at some filaments. Oh boy, this is so exciting, isn't it? All right, so first we got some Tolman Nylon 230. For the last one of these streams, I'm gonna tilt this a little bit so we get less glare, which is not helping in the slightest. There's glare galore. Hang on one sec. I'm gonna try. Yeah, there we go. There's way too much glare. All right, so this is Tolman Nylon 230. So before I wasn't gonna do a whole bunch of Tolman's filaments because they're all PET. They're for the most part PETG and nylon. But this one is special. It's called Nylon 230 because that's the temperature it prints at. This is nylon filament that is supposed to print at about the same temperatures as PETG. So even if you don't have things like a heated bed or an all-metal hot end, you can still print nylon, and also resists warping a lot more than standard nylon, so you might not even need an enclosure. So yeah, this is the nylon for the masses. That's going to be very interesting. This is one that I didn't want to buy because it's very expensive. But you folks deserve it, and you've been doing a great job of supporting me on Super Chats and Patreon, so I bought it. This is ColorFab PLA LW. This is special PLA, or LW PLA. This is special PLA blended with an additive that causes it to foam up when it gets hot. And what this allows you to do is by reducing the flow rate way below what you're used to. I'm talking 60% or something. By reducing the flow rate to 60%, the filament foams up. So you actually reduce the density of the print. So you can print things like airplane, model RC planes. Patreon link is patreon.com/Zack Freedman. Sorry, Detlev. Yeah, I should put it in the description. I keep forgetting. Anyways, this stuff is very expensive, but it has this crazy property of being able to allow it to foam up so you can make low-density prints. In fact, because the foaming is determined by things like the print speed, the flow rate, and the temperature, we can actually vary the density of the print during the print. I don't know. They also JoeBD99 asked, did you use the VariaSure TPU as well? I couldn't find a source for it. It's actually a pretty rare product. Yeah, I couldn't find a good source for it. I didn't want to order from ColorFab directly because they're based in Europe, and there's too much. I've been ordering too much stuff from Europe. I do have the Patreon on the screen. I forgot about that. Yeah, there it is. Support our projects at patreon.com/Zack Freedman. No, we're not doing the... At least for now, we're not doing the VariaSure TPU. It's very hard to print. It's hard to get. It's just very hard. But I'll try. But yeah, this is a cool one. I'm really excited to completely fail to print this. Next up, we have Filo Alpha. This is an Italian filament made in Italy. I know, right? It even says made in Italy if you don't believe me. There it is right there. Look at that. That means it's real. And this was very, very hard to get a hold of. It's not a it's not a composite, but it uses a blend of plastics that I have never even heard of before. I need to look up exactly what it is because I kind of forgot, but it uses a blend of plastics that I've never heard of before. And well, this is every filament episode. Very short TPU, by the way. It's basically lightweight PLA except with TPU instead of PLA. It's basically the same. But yeah, so this is a material that I have never heard of before, and I'm really excited to give this a shot because like if their claims are right, this has some pretty crazy properties. Like, I think it's supposed to be much stiffer than. Brooke says, "I hope it's pasta. Please be pasta." Are we gonna? Hopefully, we don't make very much Italian spaghetti. Although maybe I'll use this to print a pile of spaghetti just for fun. So before we dive into the filament samples, got a chair getting in the way. Before we dive into this box of filament samples, I want to show you this guy. Oh no! Can I get this in? Can I get this in view? Looks like we're leveled a little bit low. Can I get this in view? I really want people to see all our patrons. Hang on a sec. I want to see if I can get this guy in view. Well, close enough. Come on. Yeah, we gotta thank our patrons. I'm gonna baby step this up a little bit because it's colliding with it's drawing lines in the print. Brian Leon, thanks a lot for the generous super chat. Back payment for Patreon. I thought I was subscribed, but I wasn't. Thank you very much. I really appreciate it. If I try to print spaghetti and I fail, have I failed or succeeded? That is quite the question. All right, this filament right here. I should probably start by blacking out my address because I don't want to dox myself. I may or may not have done that in a past stream, and I feel rather stupid about it. Luckily, I have this data redactor thing. So, yeah. Okay, cool. This filament is not for sale. This filament is only available. This filament's only available from its creator, and I got in touch with him on Twitter and convinced him to send some over. And this material is PETG, or it's not PETG. It's regular PET, also sometimes known as CPE for copolyester. And what's cool about this is that it's recycled. It's recycled PET. But the really cool part of it is that it's recycled from soda bottles. And he sorts the bottles before he shreds them and turns them into filament. He even included a little old benchy here to prove that it works. So yeah, we have a whole bunch of filaments here made of different soda bottles. We have Fresca filament, we got a Coke filament, we got a ginger ale filament, we have Mountain Dew filament. I like this one. I like this one a lot. Yeah, we're gonna make a Mountain Dew benchy. Now we just need a Doritos benchy, and we're in business. Oh, we got an extra Coke just in case. So yeah, this stuff was made for me by the guy who creates it. Collects hundreds and hundreds of soda bottles, shreds them up. I think throws some chemical in there to purify it, and then extrudes it down to make filament. Yeah. So we're gonna print benchies made of recycled soda bottles. We're gonna print a Coke benchy, a Dew benchy, maybe even a ginger ale benchy. Yeah, so I'm super excited about that. And he also sent me a rather nice card, which I find very sweet. It has he wrote an inspiring message in it as well. Dream it, print it, change the world. Yeah, so this is Josh at jrt3d.com. That's Josh at jrt3d.com, and he's very active on Twitter. Yeah, so this is I'm pretty stoked about this. We're gonna print some soda benchies. Let's check back in with our let's check back in with our print here. So first layer looks a little rough. With a print this, so the bed isn't. We never got the bed perfectly level. The bed has a slight tilt towards the right side of the printer. It lists towards the starboard bow, and we never got that corrected properly. And with a print this wide, it's causing one side to be a little too close and the other side to be a little too far. So this isn't going to be the best looking print, but it'll work. Maybe we'll try to fix that later. I think it's a problem with the axis, not with. We tried to fix it before. I think it's a problem with the axis, not with the bed itself. So we might. So we're probably gonna have to do something like square the frame back up or shim the bed or something like that. Reagan, thanks a lot for the super chat. So he says, so PLA, organic polylactic acid, whatever, can break down in like 6 months being biodegradable. Have your projects aged, avoid sun. All right. So PLA is biodegradable, but that can be a little bit misleading. See, PLA is biodegradable, but in an industrial composter. It is not like it will start to degrade. Right? It'll start to degrade a little bit, but it's not going to fully. It's going to degrade a tiny bit, but it's not going to fully come apart. Is this the right one? I hope this is the right one. I ordered a lot of stuff. So as long as the parts aren't left outside, basically as long as the parts aren't left in contact with water repeatedly and they protected from UV and the heat is fine, like they last for a long time. I'm not too worried. All right, but this is the big one. This is the big one. There's this site globalfsd.com. That's globalfilamentsampledepot.com. And they are exactly what they sound like. They carry samples of exotic filaments from all across the world. And I cleaned them out. I got pretty much everything they had. So this thing is loaded to the top. Look at all these. Loaded to the top with like a dozen samples of filament. Tons of crazy stuff. What do you say we snoop around? All right, let's start at the top. This is Bentley. This is Bentley Flex. Kai Parthy is this mad scientist, I think in Germany, who makes all kinds of bizarre exotic filaments. In the last video, we talked about mold lay, and we showed off lay brick. We showed off this filament he made that's semi-flexible filament mixed with particles of limestone or something. This is their flexible filament, and it has a really weird texture. So normally flexible filament like TPU is more floppy, but this one, it's like you can bend it and it snaps right back to where it was before. And apparently after it's been printed, it's a lot more flexible. It has I think it's like a partially PVC material. I need to look up exactly what these are made of. Nobody, thanks a lot for the super chat. Two things. Sorry for repeating myself. Forgot about super chat. Did you get that filament that can be processed down to stainless steel? Oh boy. All right. No, I'm not getting that one. I forget what it's called. It's exactly what it sounds like. It's a filament that is made of metal particles suspended in a binder. And after it's done printing on regular printer, you send it in, or you use your own crucible to fuse it together. It's beyond expensive. It's ridiculously expensive. Like, we're talking, like, a sample of it is like $200 plus another $50 to have it processed. I don't have the stuff to make or borrow a kiln. And on top of that, the filament itself is very fragile. It's very brittle. When the part is printed but it hasn't yet been fused,
it's very fragile, so you have to carefully pack it and ship it. On top of that, we're talking like weeks of turnaround time. So I figured it just wasn't practical. It wasn't practical to do. Maybe I can be convinced, but I don't think it's going to happen. All right, next up is this one is called this is Tallman 3D's T-Line, and this is supposed to be if I'm remembering this right, this is supposed to leave their ultimate printer or their ultimate printing filament. It's supposed to be the clearest, the strongest layer adhesion they make, the toughest. It's supposed to be like their top of the line filament designed for like all kinds of prototypes. They tried to make like a universal prototyping filament. It's a bit flexible, and I'm pretty curious. I'm pretty curious about it. Tallman's filaments are consistently good, so I'm excited. David Tillmans, thanks a lot for the €5. Had to leave. Nice printer though. I appreciate it. I bought a second. I appreciate the super chat. Thank you very much. Yeah, I got a second sample of it because I got a few samples of some of these filaments because I'm skeptical that I'll be able to print them right the first time. All right, this one is called Biophilalinen by Two Bears. It doesn't actually have linen in it, but this is supposed to be a super duper ultra recyclable filament. I think I might be wrong on some of these. It's either super recyclable or it's partially made with like biomatter or something like that. And when it prints, it's supposed to have a texture very similar to a rough cloth. So it has a texture a lot like linen. So I'm really excited about that one. Two Bears filament is really hard to get. A lot of these filaments, by the way, cannot be it's just straight impossible to get them here in the States. I had to import them. So I've been having filaments coming in for weeks now. I started ordering for this episode like months ago to give all the filaments time to show up. Okay, this one right here is Filaprints Premium PLA X3. And I don't remember why I bought this, but apparently, like, I talked before about PLA Plus, like PLA with additives. This one has a really weird additive that I'd never heard of before, and it's supposed to have some properties that I'm very skeptical about. So, yeah, I don't remember this off the top of my head. I'd have to look it up, but it's sort of like an advanced PLA with apparently some pretty fascinating properties to it. Oh, here we go. Here's where things get weird. Here's a spicy one. This is Layfelt by Kai Parthy and Lay Filaments. This is a bizarre composite that I think is part PLA, it's part PVA, and it's part fabric fibers. So what you do is you run off your print as normal and you throw it in water, and the PVA dissolves out of it, leaving the print porous. So you end up with this very floppy print that has the texture of felt. Isn't that sick? Yeah. Isn't that rad? So this is supposed to come out feeling like having the texture, the consistency of felt when you're done printing it. And I bought another copy of this one because these composites are apparently really weird. All right, here's a fun one. This is Protopasta Matte Fiber PLA. This has a very small proportion of shredded pine, like pine wood. And it doesn't change the strength. It doesn't have as much of an effect on the print as, like, it's not a wood filament, right? It doesn't have as much of an effect on the print. The additive mainly serves to make the print rougher, gives it a rough surface. And but the other thing that's neat is that while this is printing, it's supposed to make your room smell like delicious pine trees. So it's going to make the 3D printer closet smell like Christmas. Apparently these filaments, these Protopasta fiber filaments, are really strongly aromatic. There's a cinnamon one, there's a pine one, there's a coffee one. The only one that was still in stock, though, was the pine. And I think this will be fun, again, around Christmas time when we want to whip it out, when it's relevant. Oh boy. Okay, here's a good one. This is Filamentum Vinyl 303, and the safety sticker is relevant. This is PVC filament. I didn't even know you could do PVC filament. PVC is a terrible material. Like, PVC was the one material that, like, basically at the Fat Cat Fab Lab, you had to take a class to use the laser, and I'd say about 80% of the reason why we needed that is to keep people from laser cutting PVC. When PVC gets hot, it releases chlorine gas and all kinds of byproducts, and it's terrifyingly toxic. So let's make a 3D printer filament out of it. I have no idea how this filament's going to behave, but we still, we do a fully enclosed printer. We're probably not going to print this on the Toolchanger. We're probably going to print this on a Prusa because that enclosure is ventilated. So we're going to be piping that air straight through charcoal and straight outside. So yeah, this is PVC filament. I have no idea what the properties of this are, but I'm super excited. Talon, hey, Talon, our newest mod, and also serving to be a bit of a zookeeper here in the stream chat. Thanks a lot for the donation. It's I really appreciate it. Protopasta for the win. Protopasta's filaments are excellent. Although there's only one filament that I've bought for the last episode that I was straight up incapable of getting a print done with, and that was Protopasta's gray carbon fiber. I never got that printing properly. I had to print the bottom half of the boat and it clogged, and I print the top half of the boat and it clogged, and I just cut the video. I just framed it to, hide the smokestack. Yeah. Apart from that one though, their filaments are really cool. I bought a few more of their filaments for this next episode. Maybe we'll show some of those. Oh, it even comes with instructions. Safety recommendations: avoid breathing fumes. Harmful fumes are emitted. Ventilate the room. Air filtration is needed. Pregnant women should stay away while this filament is being processed. This is another one. This is another good one. Stainless steel parts may corrode. The byproducts can corrode steel. That's the chlorine. That's pretty interesting. All right, here's another good one. Here's another weirdo. This is Porle Gel Lay. This is another one of the Kaiparthi weirdo filaments. This one is a mixture of PVA and TPU. So yeah, this is the softest filament I have ever felt in my life. I've never felt something this soft. Anyways, you're supposed to print this. You soak it in water, and you end up with this ultra floppy print that has a gel that absorbs water and has a gel consistency. So it's printing with gel. This seems like it's going to be a really, really hard filament to print with because of how soft and floppy it is. These filaments are also going to need heavy dehydrating because, TPU and PVA are both voracious humectants. They love eating waters. They love drinking water is what I'm saying. What's up? Oh, this is Guideline by Tallman. I think I was mixing it before when I was talking about their other filament. I think I confused these two. Yeah, I think I'm mixing up two of their filaments. T-Line is supposed to be a very strong filament. This one here, look at that, nice little support material. Nope. Yep. Guideline is supposed to be their all-purpose prototyping filament. They built this filament to be able to prototype anything, whether it has to survive outside, whether it has to be abrasion resistant, whether it has to be, strong, whether it has to be easy to print. They designed this filament to be their ultimate prototype anything filament, so that professional prototypers didn't have to keep a stash of different filaments around. Hygroscopic, that's what I meant. Yep, Eric Habib is right. It's hygroscopic. Yeah, so this is supposed to be their filament that a professional prototyping developer can throw at any prototype, and they always know it's going to work. So, of course, as somebody who used to do that, I'm very excited. This filament's also extremely stiff, which I like. I like a good stiff filament. Next up, oh, this is a cool one. We did carbon fiber PLA last time. But this isn't carbon fiber. This is graphene. This is graphene enhanced PLA. And I have no idea what... So what's weird is that this has enough carbon in it. Yeah, this has enough carbon in it that that it's conductive. Apparently, it's like we're talking like in the mega ohms per inch, but still, like it has enough that's conductive. But it's not rough. It doesn't have that rough texture of carbon fiber PLA. So I think this is going to be pretty interesting. Could use it for ESD safe prints. Could use it for when maybe like we want some of that extra rigidity, but we don't want that rough texture. It does conduct a tiny bit of electricity. Logan asked how long are the filaments? I don't actually know. I think these are 500 centimeters. I'm not 100% though. Capacitive sensors, yeah, that'd be perfect for it. Yeah, I'm really curious to see how this plays out. It might also print differently because graphene is like the graphene molecules are very strong, and depending on how they're grown, they could be quite long. So I don't know. I've never heard of this brand before. I never heard of Haydale. So who knows? This filament also is all going to have to be re-spooled. It's going to take for friggin' ever. All right, we're moving on to some larger samples here. All right, here's a good one. This is Layfoam. Layfoam 60 by Kai Parthy. And this is a sort of extra flexible filament. I believe this is another one of those like combination TPU. I think this is a combination TPU and PVA filament. But this one has a much higher content. It has a much lower content of PVA. And this is supposed to end up being, it's very flexible. 60 refers to the shore hardness, so 60 shore is quite soft. And once this is soaked, it's supposed to end up having an almost like neoprene texture, like a neoprene consistency. So this is going to be pretty interesting. This one could be very neat for making wearable devices, like things like nose bridges, like earpieces, like things that are in contact with your body for a long period of time. So next up, oh, it keeps going. We got tons of filaments. Let me know if this is getting boring. Here we go. These are another Kai Parthy filament. These are Laywood. This is Laywood D3. So these the Laywood filaments are all different kinds of wood. They're different kinds of wood filaments, and what's weird about this guy's wood filament is they're flexible. It's flexible. We make flexible wood. So before we made ourselves some wood benchy and we stained it. This time we're going to make a flexible wood benchy. Pretty sick. I think we'll wrap it up. There's a whole bunch of there are just tons of filaments in here. Let me see if let me snoop around here and find something particularly spicy. We got Polymaker Polymax, very strong utility filament. We got another Layfoam. This is Layfoam 40, ultra flexible, ultra soft. Let's see, we got someone asked about PCTPE. This is it. Combination of polycarbonate, one of the strongest materials, with TPE, one of the most flexible materials. And what's cool is polycarbonate is already kind of flexible. So this should be an extremely strong and abrasion-resistant flexible filament. Let's see what else we got. We got 3DX Stat. This is PETG, designed to be ESD resistant. A coconut wood filament. Coconut wood is highly sustainable. Coconuts are a good source of both wood and food. Oh, here's a good one. This is the one that took some real work to get a hold of. This is Nano Diamond PLA. This PLA is loaded with spherical nano diamonds. Yeah, it's got tiny nano diamonds in it. And it gives it all kinds of bizarre effects. The number one is that this should conduct heat better than any other filament we've shown so far. So it calls for a print temperature of 220 to 240. But this thing should be able to print at least 25% faster than normal PLA. Using this machine in a higher temperature, like using our high throughput Volcano nozzle, we should be able to really book it and print some super fast prints. I bought two of these, one to print at normal speed, one to experiment with printing at crazy high speed. So with this Nano Diamond PLA, hopefully we can print a benchy in under an hour. That's over twice as fast. I'm hoping. Let's see, we have this is nylon, except it's made using a different manufacturing process that casts it in a plate and then turns into filament. So apparently, all right, Eris Palm points out the nanodiamond PLA is going to destroy nozzles, but apparently it doesn't. Apparently, because the particles are so small and they're so round, they put almost no extra wear on a nozzle. I'm a little skeptical about that. We'll do some research, but yeah. Let's see what else we got. Oh, we have Arnitel. This is an ultra high strength engineering filament. It's supposed to be it's supposed to be about the strongest flexible filament around. Poly Support. This is Polymaker's brand of PVA type material. It's supposed to be one of the finest support materials around. We'll see how well that works. Then we got Mold Lay. This is a wax filament, and it's good for making burnout or investment molds, and it's also good for casting into because nothing sticks to it. So that's what these are for. Hopefully we can find somebody who can help fire a mold so that we can do an investment casting benchy, and another one is going to be like a silicone or resin cast benchy. And finally we have some more of our cast PLA filament, or our cast nylon filament. So yeah. Oh man, and there are more! We have more in there! This is gonna be, look, this episode is bonkers! Bonkers! We're getting material you can grow plants in. There's a filament that, like PETG with fiberglass to make, supposed to make reflective stuff. Hopefully, I hope this shows up. A retro-reflective filament. Oh, crazy stuff. Valdor asks, any ceramic rocket engine making filament for Intexa? There are ceramic filaments. I don't think it improves the temperature performance. But like Ultem, if it's okay being slightly flexible, like Ultem is stable up to like 450 Celsius. It's going to take a while to print. Yep, B-Finger's correct. This is going to take a few minutes. So it looks like our print. Let's take another look back at our print. It looks like it's going pretty well. The lines are nice and crisp. There are some boogers inside, but that's fine. I just don't think it's retracting when it's making inside movements. Yeah, I think it's the bottom, the face of it's going to look a little weird, but it doesn't seem. Yeah, I'm not hearing any clicking or anything, and I'm not seeing any evidence of misfeeding. So I think this is going to work pretty well. I think this is gonna do it. It's pretty exciting. The truth is I don't know about things like rockets, and whatnot. I do know that I do know of a company, at least one company that uses one of these high temperature engineering materials. Maybe it's Peak. Anyways, he prints suppressors with it, like gun suppressors. So if it can contain, all the gases coming out of a muzzle, I'd imagine it can contain at least to some extent an explosion. Let's see. Quint Van Dyke asks, how much noise does the printer make? What you're hearing is pretty much what there is. This is a pretty sensitive mic. Yeah. So it's quite quiet. It's going to make more noise when I get it up off the carpet and put it on something hard to keep it from vibrating. Some of that ringing is caused by the printer itself jiggling on the floor. Yeah, I haven't gone too deep into tuning any of the settings yet. I'll probably do that off camera. I don't think it's going to be terribly interesting. But yeah. So let's see. Oh, I have the keyhole turned off. That's why we're having trouble. Yeah, I've got the mic turned up a little too high. There we go. Alrighty. Detlev asks. Let's see. Beefing says, "Will you be aiming for a 10-minute benchy?" No, I'm no speed demon. I don't find it fun to dial in a printer, and getting something that fast. Getting something that fast can be a real problem. Ledneck points out that a suppressor is just an instantaneous blast, while a rocket combustion chamber needs to withstand sustained temperature and pressure. That's yeah, that seems accurate. There's look, 3D printing is not perfect for everything. There are certain things that you're still better off machining or casting, and yeah, all that stuff. So yeah, control panel is still printing. It's unlikely it's gonna take a while to finish the job. it's going to take a while to finish the job here because we also have to print the second part, and that part's much thicker. It's probably going to take closer to 4 hours, but we'll see. Beefing, it says Stefan from CNC Kitchen. I'm Stefan, and welcome to CNC Kitchen. Recommends a slab of concrete on top of foam on a table. I might do that. I'm debating whether to move this guy into the 3D printer closet or leave it out here. Putting it in the 3D printer closet will mean that we're going to have to move one, maybe both Prussias, but who knows? I've been thinking of taking that idea and instead of putting the concrete on foam, instead put it on silicone. Like get like a thick silicone like drying sheet or something and mount it on that, because I think foam will start sagging over time, which I don't know if it'll have that much of an impact, but seem to be having some are we having some trouble with the stream, or I think it's my computer. My stream just buffered for a second, but my stream just buffered for a second, but I think that might have been on me. I have a few things going here. Let's see. Brooke has been trying to get my attention. Oh no! Oh, nope, never mind. I'm dumb. Oh, Black Dynamite, I am very sorry for missing your super chat. What about steel or iron filament? I got mine from Micro Center for $50 for a half kilo. That's about... Yeah, in the last Every Filament episode, I used Protopasta's steel and iron filaments, which I think that's what Micro Center carries. They were very expensive. I already did that in the past. They're pretty sick. They've been sitting on my shelf. I just can't think of anything to do with them. They're very, very cool, though. David Tillmans, thanks a lot for the euro. Had to leave. Nice printer, though. Thank you very much, and thank you very much for joining us. Appreciate having you. Yeah. So, my YouTube's been acting up. YouTube's been really weird. I've also been noticing that their encrypted RTMP endpoint is very unstable compared to their non-encrypted. So, I don't know. When you're I thought when you're doing hardware, everything is your enemy. But now I know for sure that when you're streaming, everything is the enemy. I'm hearing some rough sounds coming from the printer. Looks like we have a bit of a booger. Yep, that's what happened. Yeah. Looks like a bit of a booger came off. Let me grab my forceps and yank it out of there. So what's happening is because one side of the bed is a bit higher than the other, the filament's building up on the nozzle on one side of the bed. When it moves over to the other, it has enough room to wiggle off, so it's built up a booger. So yeah, we're gonna have to square that thing up after all's said and done. So yeah, them's the breaks. Blasto Supreme asked a question that everyone should already know the answer to. What's my favorite Pokemon? Folks should already know the answer to that one. Where is he? I already know him. All about that quag life. Yeah, I don't think the problem is on my side. I think the problem is on YouTube's server, not my client. Still, it's amazing that we've managed to send this much data so far at all, and still managed to keep the stream stable. It's really crazy. Yeah. Anyways, yep. QuagSire's my boy. So yeah, now this is kind of awkward because now we're waiting on this thing to finish, and I guess we could try to mess around with setting up a multi-material print. Try to set up a multi-material print. We could we could also take a look at some future projects or work on this. I don't understand the QuagSire evolutionary line. Like, Whooper is obviously an axolotl, and QuagSire is obviously a manatee, and I don't know why they made an axolotl evolve into a manatee, unless they, just needed... Maybe he was, like, Maybe they just needed to fill a gap. Mike Vuga asks, any luck with Starlink? I got in touch with my ISP provided me with a cell failover, and I ran some benchmarks on it, and it should be fast enough. We can drop the resolution. It should keep the stream going if necessary. So I've got that. I haven't fully tested that. MicroTix routing. It's not very easy. It's designed for pros. It's not easy to set up. But yeah. We're going to do. We're going to set that. We're going to set that thing up so that it'll fail over to a cell network, and if that's still causing problems, then we'll look into Skylink or something. Starlink. Starlink's very, very expensive, and we have to. Our leasing agreement, strictly speaking, doesn't let us put up an antenna, but everyone does. So who knows? A buddy of Tinster747 says, a buddy of mine always said, you don't F-ol with the shuckle. Shuckle plus Trick Room is still one of my very favorite pieces of jank in the entire series. I love Shuckle, Shuckle, Deoxys Attack Mode, Blissey, all of those Pokemon, all those glass cannon Pokemon where they put all the numbers into one stat and then just built the Pokemon around it. I love all of them. They're so gimmicky. I just love gimmicks in RPGs. So much fun. So yeah, we're getting a little aimless. Let's figure out what we're gonna do from now. This guy is about half done. So let's see. We have. I think it's about half done. It says it's got 17 minutes left. I don't really believe that though. I think it's probably closer to 45 minutes, unless it's speeding up unless it's going faster on the printer than in the slicer, which I don't understand. Craft Computing, thank you so much for the Craft Computing, another excellent YouTube channel. Definitely got to go check him out. MicroTix Router OS is a bear when you get into the weeds. MicroTix Router OS is it's a bear from a distance. Nothing about it is easy to use, but that's not what. But I knew. Don't get me I'm not complaining. I knew that going in. I bought it because I need to have granular control over everything. I got to be able to program in my own QoS rules. I need bulletproof hardware. There's just one of the boogers made its way onto the part. We're gonna have to slice that off. Lodge Blake Nielsen recommends print a fractal vice. Thingiverse is recommending them a lot. There have been a couple popular videos, and they've also been very popular on Instagram. A fractal vice is a vice that has basically has a pair of pivoting. It's just a regular vice, except instead of having a pair of jaws, the jaws have these pivoting clamps. And those, in turn, have pivoting clamps, and those have pivoting clamps. So it kind of can form around an irregularly shaped object. And I don't think I would get very much, I don't know. I don't think I could make a video out of it. Maybe I could. Another thing we have to do, another thing on the to-do list is my Prusa printer, one of the bearings died, and I bought some IGUS polymer bearings. So we can go ahead and swap that out. What do we... Z-Ender Game says, what have I come to? Killing a bit of time while we wait for a print to finish, I think is the main one. Yeah. But, no, this is kind of awkward, because I wanted to... I wanted to show you around the printer. We got a little work to do. We could dive into the scripts and try to... We could drive into the scripts about to try to keep the thing from crashing every time we cancel a print, and to program in filaments and stuff. I feel like that's kind of boring though. Alternately, we could wire up the ergoblades. That's another thing we could do. We could wire up the ergoblades. Yeah. Let's. What do you say? You can get IGUS filament. That filament is also bananas expensive. It's crazy, crazy expensive. So yeah, let's we could wire those up. Could wire up our ergobleds. Let's go for it. So let's think. So the ergobleds are neopixels, so those could use a 5-volt microcontroller. So let's go grab some micros and let's grab some micros and let's pick something juicy. So most of these are 3-volt devices, and sometimes they'll drive it, sometimes they won't. I've already confirmed that a Pi Pico will drive neopixels, so it's going to be a good Pi Pico project. Could also tie up a regular Arduino, or could do an Arduino Nano or something. I'm thinking we go Pi Pico with this one. I'm thinking we peak this one. The question, yeah. So Pi Pico does take 5 volts in, so we can certainly run that. Yeah, let's do a little Pico. Ultimately, we can also hook up cameras. We can also try to hook up some cameras to this. Get a Pi, maybe get a Pi in there. I don't want the same thing controlling all of it though. But yeah, we don't need this. Yeah, so Pi Pico, and let's see. I'm wiring this thing. I wired that thing up for what? Oh. Let's see, so we're going to have to wire up some of our own cables, which is also fine. And those are going to use some of these leftover connectors. Here's a question. Is it possible to plug the neopixels directly in... Is it possible to plug the neopixels directly into the Duet or the Duex? I don't think it is. I don't think it is. No, I think we're stuck doing this. So yeah, here we go. So really, all we need is to connect this guy to a board that lets us mount it, and add in a few right-angle headers to plug in these guys. Actually, maybe the other side will. Yeah, I think the other side will just use these. So we want some right-angle headers. Chad says Duet has a PWM pin. It has a bunch of them, but yeah, these are addressable LEDs. Yikes. This is really mashing the filament in there. I think our Z-axis might not be calibrated properly, but that doesn't make any sense because I print a calibration cube. I think we just have to level the bed. All right. So, anyways, let's hook this. So let's fire up the soldering iron. It's not going to work because it's not plugged in. I unplugged it to do some soldering on the Toolchanger. Yeah. Let's just make ourselves a quick and dirty breakout board. So let's bring this in. All right. We need a little bit of strip board. Let's see if this is, yep. A little bit of strip board. This doesn't give us a lot of room to move around. Maybe, I guess we could just plug it in to a bigger piece. But, let's see. It's just a very large micro. Sorry about the wobbling there, folks. Yeah. All right. So let's plan our attack here. I am going to just rearrange the furniture a tiny bit to get this closer to where I am actually working. All right. So we're going to want, so let's see. We're going to put this guy in here. I like to leave 3 holes on each side. So we're going to cut this 1, 2, 3. So we'll cut this here. And where are we gonna plug this in? Let's leave ourselves some room here to plug these in. So that's where we're going to cut this. Okay, we need a knife, and I don't remember where I put my cutting mat. So let's just take this off of here, and let's be careful not to cut the table unnecessarily. This is this is just phenolic paper, so it's not. This isn't a fiberglass circuit board. It's much easier to cut. So we just want to score both sides. Let's see this side. And we want to trace the holes on this side. Oh, we haven't talked about Things in a while. Yeah, the stream is sponsored by Things.com. So no matter what kind of 3D printing you do, or hell, even if you don't 3D print at all, and you just model, Things.com has got you covered. They make it super easy to upload and share your stuff. They now have a versioning system, so there's no confusion when you update a model. Everyone can know that you've done an update and keep the parts separate. And it's super easy to browse. Their search functionality they've been improving that like crazy, and it's now better than ever. And each thing loads in like a second, with no messing around, no pictures, none of that crap. Just model after model, super easy to download. And if you check their site out on a phone, you can use their augmented reality to see your board in sort of real life. Yeah, so thanks a lot to Things.com for sponsoring Voidstar Lab and for making this entire thing possible, and for keeping the lights on. We wouldn't have to worry about whether Starlink is good enough if Things wasn't around, because we wouldn't be able to pay for our internet bill. So thanks a lot to Things for making Voidstar Lab happen. So now I'm just going to cut the traces. Let's see. Yep. Alright, just going to cut these traces so the two sides don't get linked together. We're going to need some rectangular headers, because I want to socket this up. Socket to me. Alright. I really wish the pin numbers were on the top. I'm sure I'm not the only person. Who expressed that, but do I ever? And I think we'll program this in Adafruit's Circuit Python, because as I was trying to proselytize on the Discord a few days ago, Python rules. Or is that just yesterday? I don't know. Time passes so slowly. There's just so much to do every day. All right. So then this guy is going to go in here. It's very unnerving that I can hear the nozzle dragging along the top layer. We gotta fix that. So yeah, I'm just flattening these, flattening the corner pins, because that will keep it in place. I said I'm flattening the corner pins. Flatten corner pin. There we go. Yeah, that'll keep it from falling out while I solder it. So yeah, let's grab some solder and make it happen. Python is the best. Python is the best. Can you even write assembler on the PyPico? Like, I know you kind of have to if you're using the whatever those logic coprocessor, whatever like the I/O coprocessor things are. I know you have to write some assembler for that, but I certainly don't have the skills to do stuff like that. Let's see. Alright, let's pop this in like so, and let's do a little soldering. This is a really simple, drawing, or it's a really simple circuit. Yes, that's right. I was thinking schematic. I said drawing. I meant circuit. It's a very simple circuit. Really, all we're doing is distributing 5 volts and maybe adding a capacitor or two if we need, and wiring this up to the I/O. But I like to leave a little bit of extra space in case we want to add some features later. You never know what you're going to need. You never know if you don't go. You never shine if you don't glow. These perf boards are old as heck. Solder's not flowing very well on them. Hey now, an all-star. Alright, let's find something to talk about from chat. Python. Oh, Python. I love Python. A lot of people give Python guff because they say it's not as high performance as like C++, and I disagree. It is extremely high performance, not on your computing resources, but on your developer resources. Computers these days, even microcontrollers, are so gratuitously powerful that you don't always need a reason to conserve them. Like, I would rather have code that have code that I can develop quickly than code that runs quickly, because developer cycles are always more scarce than clock cycles. So that's why I like Python, because it's just faster to develop, to deploy, and just in general. I get that, you've been alright, fine, to be using C++ for 20 years and switching over would be slower. Alright, but I wasn't. So yeah, Python for life. Python for life on. Python gang. So yeah, solder in this. The solder, the board, it's just not wetting. It's just not wetting well onto. It's just not wetting well onto the copper. B-Fingit is calling me out for. I'm on the Fusion team with forget about optimization. Look, it's the nature of the game. Like, it's not optimized. It's slow, but we use it. So why make it faster? The only incentive they would have to make it faster is if a competitor's program came along and, scratched the same itch, did the same stuff, and was faster. And even then, not every user would push it to the limit, so you wouldn't even know that. Sometimes when you're optimizing your code, you're doing a lot of work for no reason. Who was it that said premature optimization is the root of all evil? Yeah, premature optimization is the root of all evil. Jaden Dester, thank you so much for the super chat. Super generous. This is my exact argument for using Python. Honestly, like, Python has been slowly eating up all of my coding. Like, I barely even write shell scripts anymore. Like, I'm just using like the OS and sys modules in Python. It's just so much faster and easier, and it's so much easier to debug, and it's easier to deploy on a new system, and just, oh man, friggin' love Python. It's not just the language either. Like, that's another misconception. It's when you're picking a program, when you're choosing how to program, you're not just picking a language. You're picking IDEs, you're picking libraries, you're picking support, you're picking pre-existing code, you're picking the ability to deploy it on a new system. Right? Like, sometimes the hardest part, sometimes people won't use your project because they don't want to set up a C compiler. With Python, they probably already have some version of Python already installed, and the script is just going to run. You don't have to worry about what architecture they're running. There are ways to get around that using makefiles, but do you know them? Will you use them? I won't. I don't. Yeah, this is causing all kinds of problems. This perf board, it just does not want to make friends with the solder. I think we might have to bring in the flux. You got to be careful using flux on these unmasked boards, because it tends to corrode too much of the copper. You can even end up eating holes into your boards. I mean, this isn't the prettiest job I've ever done, but it'll work. The perfect is the nemesis of the finished. Alright, so next thing we're going to need are some right angle headers. Right angle headers. Here we go. No, not those. These. Yeah. Alright. Here we go. I think I got these from, like, Electronics Goldmine, like, a long time ago. Oh, remember that? That was like one of our earliest streams. I bought some boxes from Electronics Goldmine, and we just built them. Like that was it. That was a stream. Or no, we built them. We opened them up and saw what we got. Like, that's it. That was the whole stream. That's not. Yeah, people didn't like that stream very much. I think it was kind of. I think people thought it was half-assed, and it was. Like, you know, I'm not gonna have any pretenses. But I thought that was a lot of fun. Those were disappointing boxes, though. Those were some disappointing boxes. The other surprise boxes I got from Electronics Goldmine in the past have been much spicier. These are falling out, so I think we're going to use our helping hands. Yeah, the other ones I've got have been way spicier. That one was kind of mild by comparison. Tasted like American food. When Americans, what's the saying? When Americans think spices, they're thinking salt. Well, yeah. Maybe we should do that again. I love a mystery box. Brooke knows. Brooke can tell you. I love mystery stuff. I love not knowing what's going to happen. I like a surprise. I'm not even sure I've used any of the parts in the mystery box. I think I tried to use some of the transistors, but they were mislabeled. I ended up just burning them out. Alrighty. So, yeah, we want. Alright, let me grab a bit of LED tape for reference. Where is that? Here it is. Alright. So, here's the LED tape we're using. It is laid out like so. So these are going to go ground signal 5 volts. So that's exactly what we are going to do here. I'm just going to label this so we know. Ground, signal, and voltage.
P.O. box address?
Brooke is.
Some people are asking for it in chat to send you mystery things.
I do like mystery things. Apparently some people are asking about it. We finally got a P.O. box. That's right. We finally did it. It was a big pain in the butt. I blocked it just as I expected. I waited for a half hour in line, and then I blocked the line behind me for a half hour. It was great. Okay, here's a question. Does it matter which pin we use? I don't think it, does it matter which GPIO we use for our digital pins? I don't think it actually matters. So I'm just going to go with that. So these are labeled GP. Yeah, I don't have as much experience. I don't have as much experience building with these. So I think we're going to use. Oh hey, we're coming to the end of our print. Yeah, we're going to use GP 14 and 15. We're probably going to need some. Gonna have a hard time doing this without any jumper wire, huh? Where did I put the jumper wire? Oh, it's really buried in there, isn't it? There it is. Everything's fine. I'm actually running kind of low on jumper wire. So this is wire. This is basically solid wire that doesn't have. It's not basically. It's what it is. It's solid wire with no insulation, and that makes it really nice for working with strip board because doesn't need insulation because we'd just be, you know, pulling it off anyways. So let's straighten some out. Here's how you straighten a wire. Here's how you straighten a wire. Grab one end with a pair of pliers, or your stripper. Grab the other end of the pair of pliers and just give it a little stretch, and knock some screws off your desk. The more screws you knock off your desk, the better it works. So yeah, what's the bottom one here? Is there one that's unlabeled? No, it's 14 and 15. They just put holes here. Why didn't they put these on top? This is so annoying. Why? Why? They could have just put them on top. There's definitely enough room here to put labels. Like, come on. Alright. Let's make ourselves a little jumpy jump. Put that in here. Alright. And then we'll jump over. Alright, the next pin over is going to get the, let's see, it's going to get the other strip. I have to wire them up separately. I didn't connect the two strips because then we'd have wires flying all over the printer, but in retrospect it might have been smarter to do it that way. So let's put this here and here. Ah, very nice. And we're going to trim this off. And then I think the third one, yeah, third pin from the bottom on both sides is ground. So let's do that one next. So we got ground. It's going, yeah, we got the ground pin going here. Ah, jeez. There we go. Alright. So got the ground pin, and then we're just going to jump from, I hope we still have enough left. Basically, we're just going to jump from this ground pin to here. Maybe I should move the camera down a little bit so folks can see what is going on. Nope, this is done. Alright, let's move our camera. Now that I'm sitting closer to the table, I'm not going to whack myself in the head. Looks like our slicer, let's see. Oh, that's it. We're done. We're done. Did I mute myself? That's it. We're done. Woohoo. Alright, I probably want to remove this before it cools off too much and breaks the bed. So, yeah. Let's see. Alright. Yeah, not the nicest. Yeah, the quality's not the best. Okay. Let's see. So yeah, the quality's not the best, but this isn't bad for... It's alright. Yeah, it's alright. Not the nicest. It's got a little ridge, some ridges on the top. We got some boogers and blobs. But considering how, it's like a 0.5 millimeter tilted or something. So all things considered, I think this came out just fine. I'm going to reach back here, grab a knife. So let's just strip off the... let's see. We're going to use the knife to strip off the brim. Get this booger off of here too. Come on, booger. Get out of there. Yeah, the boogers are caused by plastic building up on the extruder, which, if we were leveled, more consistently, we got our Z offsets really perfect, that would happen a lot less. But new everyone knows it. The new printer blues. Perfect continues to be the enemy of the finished. So yeah, let's quickly strip this off and let's check for any obstructions inside that are. Yep, here we go. Going to get rid of anything that's going to keep us from smoothly laying down our display. In we go. Come on. It doesn't matter if this part gets gouged up because it's going to get covered by a display. Let's get some of the crud off here. Okay. Time for a test fit. Okay, so I think this is going to go here. Yep. Test fit. Oh, it's like a glove. Like a glove. Look at that. Look at that. Perfectly lined up. Like a glove. All right, looking pretty solid. Quality's not the best, but whatever. Whatever. All right, so what do you say we print the other half? Yeah, let's print the other half. Come with me. Oh, come with me. Let me get my exotic filaments out of the way. Let us set up the other one for printing. Whoop, up we go. It's printing time. All right. So we're going to go back to Fusion 360. We're going to again export this as an STL. We're not going straight to printing. We'll call this control panel bottom. Let's go back to our slicer. Let's get that out of there. And let's move. What's going on here? Yeah, let's move this into here. All right. So we shouldn't need any support material. Max, thanks a lot for the euro. I don't know if this has been asked yet, but what's your favorite printer and filament? I don't think I'm really qualified to answer the first one because I do nearly everything on a Prusa. Let's see. Yeah, I use a Prusa for pretty much everything. Actually, we don't need a brim for this. So this is giving me a quote of 4 hours. I'll get back to you in just one sec. I just want to set this up so we can get it going. Here's what we'll do. Let's really open this up. I'm going to revert all of these back to the default values. This is the default stuff for all the profiles. So this should speed it up rather a lot, but it might cause one of the tools to shake off, but that's exactly what you folks want to see. All right, so this is now going to take 3.5 hours. This is going to be the back side, so I'm thinking we raise this to 0.25 millimeters. Print some extra thick layers. All right, so this brings us down to 3 hours. That takes us. So we're not going to finish this today. Unfortunately, we're going to have to end this. Yeah, unfortunately, we only have like an hour or so left in the stream. So I'm just going to switch this back to 0.2. But at the very least, we can watch this thing get started. So let's slice. Let's export. Let's get back to Squirtsephone's control panel. Let's load it up. Make it work. Actually, first I'm a little skeptical about the post about the cleanup script that runs at the end. So I still have to figure out something to actually do with the heads-up display during these streams. It's harder than it sounds. Wait a second, why is my monitor not going all the way? That's weird. It wasn't filling the screen. All right. Let's load it in, and should work. I do need to shave Michael Reed. Michael Reed is correct. Oh wait, why is it picking up that extruder? I thought I changed that. Oh, it's picking up the wrong extruder. and then it's going to crash again when I cancel it. Oh my. All right. So it's going to be printing this in PLA at way too high of a temperature. Oh no. Oh, I should have seen from the color. Yep, there it is. Ah, I'm dumb. I'm dumb. Maybe we should do the emergency stream, or maybe we should do the emergency stop to move on with get on with our lives. Yeah. 1 second. Johnny, printer. Oh, Michael Cutler, thanks a lot for the Singapore pesos. Just joined the stream, 6 a.m. here in Singapore. Was this machine sponsored, etc.? I missed the start. Well, greetings to my favorite island city-state. The machine was the printer itself, and some of the materials were sponsored, but the sponsor of this stream is Thangs, not E3D. E3D graciously donated the printer, but things handled the stream. So let's home all this stuff. We'll run our lights on script. What's going on here? Why isn't this displaying anything? What's going on here? Hang on a second. Why is our view? Damn it, Camlink, you missed all the fun. Jeez Louise. Okay. So let's upload the job and let's run it. It has just been uploaded. All right. So Max earlier asked, "What? Why isn't my Camlink doing its thing?" Oh, is it because I ran over it? Because I ran over the cable and pulled it out? One moment. Is it still working? Yeah. All right. I had run over the HDMI cable and I was pulling the Camlink out of my computer. That was the problem. Okay. Favorite printer. I mean, almost all my printing experience is on Prusa i3 Mark IIIs, so I can say that, but it's not really. I don't know. I feel like I'm not one to answer this question. As for filament, favorite filament is probably carbon fiber PETG. Yeah, I think it's carbon fiber PETG. It's just got all the best properties, and it looks amazing. PETG by itself is great, and adding in some carbon fiber just it gets rid of all its weaknesses. Right? It doesn't sag anymore. Supports remove more easily. The surface finish is great. Carbon fiber PETG is really the best of all worlds. A Blade of Kitten, how's it going? A regular on our Discord. Welcome, and thank you so much for the very generous super chat. Favorite duck, like species of duck, or like a specific duck, or like does a fictional duck count? Fictional ducks? Because I don't really like too many fictional ducks, but I saw this. I saw this great. I saw this great GIF for like this mother duck is walking her little baby ducks, and they walk over a storm drain, and like all the baby ducks fall down the storm drain, and the mom just like takes another step and looks around. It's like, oh no. And then then it cuts to a guy. Like a guy takes off the grate and he's like fishing all the ducklings out one by one. Oh, I love that duck. That's a great duck. That is a top quality duck. Good duck. I'm just making sure the first layer goes down smooth. I think I want to raise this. A tiny bit. Yeah, we're gonna baby step it up. it was heartwarming. Yeah, it was heartwarming. I don't think the ducks got hurt from the fall. They're very light, so they don't have a lot of momentum. But Sanjay, thank you so much for thank you so much for the super chat. Sanjay is a member of the E3D team. E3 into house pseudo sponsoring. You didn't have to. Contributing the printer was way more than I could ever ask for. The printer's going great. Upgrade and Improve asks, why are you using Super Slicer instead of Cura? That's because Super Slicer has... So according to Rene, like I was following Rene's instructions, that's the short answer. The long answer is because apparently Super Slicer has particularly good multi-material handling, which is, even though we're not printing multi-material, we still want it to play nice with the system. Alright, so you'll notice that the right side of this print is not going to go down very, very well, but the left side should be almost perfect. It's because the bed is like this. It looks terrifying. Here, take a look at how bad my bed is. Yeah, this is awful. So yeah, normally this isn't causing much of a problem because the prints are very small. They're only in a small part of the bed, but yeah. Also, 420 blaze it. Thanks a lot to all the very generous super chats. You guys and gals have been most excellent. Max Via, I think. I hope I'm pronouncing your name right. Thanks again for very generous Euro super chat. Favorite game, and what do you think of Watch Dogs? It's personally my favorite. I'm gonna be honest. I never played Watch Dogs. I get let's just say I get a little into open world games, and I try to be very selective about which ones I play. And the reviews for Watch Dogs were not positive. So I decided against it. Plus, I don't know, I'm not a fan of Ubisoft's RPGs, or Ubisoft's open world games. Like, they start great, but then they just drag in the middle. My favorite game of all time, it's hard to say. Like, if we're talking about which one I think is the best, like, full stop, the best game ever created, is probably it has to be Half-Life 2. Like, it basically, every FPS since is based on, like, every FPS since pulls massive influence from Half-Life 2. And, you know, it was a technical leap. It created the Source engine that revolutionized gaming. You've got the that first layer is looking mighty sus. I'm gonna baby step this down a little bit for now, just to make sure it sticks. Yeah. In terms of which game I've played the most, it's probably Oblivion or Fallout 3. I think they're great. As for which game I think is the straight up best, it's probably Binding of Isaac. It's probably the Binding of Isaac, or Magic the Gathering. Although Magic's had a lot of problems lately, so yeah, maybe not Magic. I know, right? Binding of Isaac's got to be up there, just because, like, the biggest problem. Binding of Isaac, maybe Slay the Spire, maybe Synthetic, but the problem with a lot of these roguelikes is that sometimes you just get bomb runs that just wreck everything, and sometimes you get oftentimes you just get, like, just a flaccid, limp garbage run that you just know you're not going to be able to get, like, you know it's already lost before it started. Binding of Isaac, sure, yeah, you can get some bomb diggity runs, but it's much rarer that you have, like, basically, like, you have to get much further, like, enter the gungeon to an extent, too. You have to get much further into the game before you're like, alright, this run just completely blows. Like, basically, you've already beaten the game halfway. You've already beaten the run halfway before you're like, alright, this sucks. I can't redeem this. But most of the time, most runs are doable. I've basically cut out all the video games since I just don't have the time. I just don't have the time anymore. The only games that I've been playing a lot of recently are virtual reality. Yeah, most of them are. Most of the games I play are VR because it forces me to clean the room, and there's a physical limit to how long I can play VR games. Like, I can't get hooked on a VR game and play it like all night because I'll get sick and I'll barf everywhere. Ablative Kitten, thanks so much for the super chat, Ablative Kitten. Have you ever tried the Game Raft? Very relaxing, I love it. I never heard of it. Never heard of it. Oh boy, son. Alright. Thank you so much for the very generous super chat. Never heard of it. I gotta look that up. Sanjay just stealth mode dropped a bomb on our stream chat. Sanjay says, "Wait until you see we've been working on a Superseed Nozzle X. I've been using a lot of Nozzle X's, and they're great. And meanwhile, you're making it obsolete. You better send me one of those. These Nozzle X's have been awesome. I can't even imagine what the weapon to surpass Nozzle X would do." Let's turn our attention. Let's turn our attention though back here so we can. Geez, I dropped this thing like a. Yeah. Ledneck says no time for video games is a sad relatable situation. All right, there's a bit of a personal quirk involved in this. In that, I don't like chilling out for just a few minutes. I'd rather, if I can't get a good tour, if I can't get, enough time to really get into it, right? Basically, if I'm playing video games, I either want to play for 3 hours or I want to play for no hours. I'd rather, if all I can do is, try to jam in a quick game, I'd rather just work. It's just not worth it. Okay. So, yeah, with video games, though, I don't know. I have a really hard time getting myself to stop. So it's not so much not having the time as the time is being spent irresponsibly. I think I might, I spotted some patterns in myself that were similar to addiction. And, if you're addicted to something, moderation doesn't exist. You either are a full-blown life-wasting addict or you quit. So, I quit. With the VR, to an extent, I don't know, the VR is almost, it's not really playing video games, it doesn't, at least it doesn't feel like it. I don't feel compelled to stay up all night playing it. Or, it's just, I feel like it's different enough. It's also, there's an element of, there's an element of a physical activity to it as well. Every time I take off the VR headset, I am just drenched in sweat. I don't know about you folks, but I really work up a lather. But I've been noodling around in some games, but I've been noodling around a little bit. But for the most part, if you can't control yourself, you can't have it. The nature of the game, so to speak. I've been trying so hard to keep this in frame, and I didn't even have the camera set up properly, so there we go. Okay, question. Which one of these is 5 volts? I think it's going to be this one, the top right one. Because is it V-bus or V-sys? What's the difference there? Is V-bus... V-bus has to be 5 volts, but is there a reason to use that instead of the pin labeled V-sys? I don't know what any of this means. I have no idea what I am doing. Yeah. On top of that, hot dogs, horseshoes, and hand grenades, the developer is... Alright, so some... People occasionally point out that I'm in my Discord very often, and I try really hard to sincerely and often, hang out with the community. That, I don't just set up a community and let it sit. I think... If it's my community, I should be a part of it. And I got that from hot dogs, horseshoes, and hand grenades. That's how the lead developer, Anton, runs things, and I think it is a super rad way to respect your community. So, yeah. If you ever wonder part of why I take that so seriously is because I've been inspired by Anton Hand, the hot dogs, horseshoes, and hand grenades developer. I can't believe they're still working on that game. It's ridiculous. That game is never going out of early access. It's just going to be in perpetual beta. Not in a negative way. It's just the game is intrinsically just so nichey and so nerdy. I can see that. The first layer, the first layer looks a little sketch on the right side. I don't think it'll be a problem.
Upgrade and improve says your first layer is peeling.
Yeah, I'm just saying something. I'm just saying it. Yeah, I'm gonna wait until the second layer go. I'm aware that the first layer looks a little sus. I'm gonna wait till the second layer goes down to see if it stays in place. Because yeah. Oh, wait, why am I doing this? We have a for crying out loud. We have helping hands. Let me see how bad the damage is. Is that enough to ruin the print? I'm not sure that's enough to ruin the print. I think I'm going to wait till the second layer goes down, and then we'll see if there's any any peeling or anything along the way. Let's get this guy up in this guy. Yeah, there we go. All right, and yeah. Then next step here is we have to make some wires, and then yeah, we got to make some connector cables to actually connect this guy to our. Make some connector cables to actually wire this thing into our ergobleds, and then we are in Ergobled City. The cables are really simple. There's literally we're going to be crimping 12 rectangular connectors and running some cable sheathing, shrinking it, some heat shrink, and that's it. Bob's your uncle. I don't know what we're going to plug this into though. I guess we could. Now that I'm thinking about it, like we could probably plug this into the Raspberry Pi, right? You think that would be That wouldn't be a terrible idea. That way we can always change routines and stuff from the Pi. Because I don't think there's any sensible way for the DuX itself to communicate directly with this. Sanjay's dropping wisdom about exotic nozzles and funky filaments. If you're listening to this, you might want to tab over and get caught up on the chat. All right, snippity snip snip snip. All right, let's just double check. Digital. All right, let's see. Digital. Going to power. Going to ground. Power, ground. All right, so this looks about right. All right, let's make ourselves some connectors. Alrighty. Let's put our toys away. We're getting a little messy here. Lady headers. I'll go here. Lady headers go here. All right, we're gonna need some wire. Which one do we want? We want some silicone wire. How much of this do we still have? Not very much. Yeah. Hang on, I'll be there in just one sec. I have a lot of 2-conductor wire. I don't have a lot of. Damn it! I don't have a lot of 3-conductor wire. So let's see. So in here we've got. Looks like we got a fair amount of yellow and green. I think we can use that. I don't think we have any cables we can reuse, unfortunately. Although, hang on a second. I got an idea. We ended up with a lot of spare cables left over from assembling this 3D printer. So let's put some of those to work. All right, here we go. So we got these stepper motor cables that have a 6-pin. They have a 6-pin connector on this side, and they have a 4-pin dealio on this side. But nothing forces us to actually use all the conductors. So yeah, I think we should repurpose these. Yes, that's what we propose. Alright, get ourselves a sharp new probe, because we have updated them. Alright, so yeah, we'll just reuse these. So what I'm going to do here is going to remove, we're going to disassemble the connector and reassemble the appropriate wires in a 3 position. I don't want 1 position, I want all positions! Yeah, so we'll reassemble that in a 3, and then we'll crimp on the connector for the other side, and that's it. The best part of this is we can test this while the printer is printing, because it doesn't matter, because it doesn't actually connect to the printer. It's its own separate device. We'll eventually be powering it off the printer, but you know. All right, and these we just straight up don't. We straight up we don't care about these. Get out of here. Okay, so we want so we don't want the blue. We don't care about that one. So let's just yank this one out. I don't know what we'll use it for, but we use every part of the buffalo here. All right, check that out. Neat, tidy cables. Let's find ourselves a 3-pin. Connector. I had one earlier, but I think I threw it back. We'll use that 4-pin connector later. Waste not, want not. Come on, CoreXY, thank you very much. CoreXY, thank you very much for the £5. This is for the Fifth Element reference. Oh, I love the Fifth Element. It's such a good movie. Thank you very much. I appreciate it. I gotta work more Fifth Element references in. All right, the pin marked with the arrow is always ground. Always. That's the rule. I don't make the rules, but I kind of do. All right, and that's 1, 2, 3 goes in there. Yep, all 3 are locked into place. And now on the other side, I'm going to trim this down a little more. Let's strip these a tiny bit, and we're going to crimp them onto the. So I already soldered on the bigger Molex style connectors onto the LED strips. So we're going to use those. We're going to need some crimps. So yeah. Look at all these crimps and stuff we have left over. So, yeah, I'm going to need a crimp tool. I should probably close the knife before I stab myself. The stream is super green. It's emerald green. Which one of these looks correct? I think that one seems about right. All right. So let's get this in where folks can actually see it. I think this crimp tool is, yep, I put it in backwards. Yep, I was crimping it backwards. Big crimping. There we go. Ah, nice crimp. And next one. Ah, beautiful. Perfect crimp. Ruben Hirsch, thanks so much for the super chat. Print is failing. Oh no! Oh, the print is most certainly failing. That is 100% true. Let's deal with that. Pause the print. All right. Oh, it is the cancel script. Huh. There you go. Yep, it is definitely the cancel script that's causing the problem. So, all right. It looks like our. Alrighty. So, looks like our print's not in great shape, but it wasn't all for naught. We did get some intel that will help us figure out why why that script is failing. It seems to be the cancel script that's causing the problems, not the pause script, not the cancel script. So, yeah, I think we'll let this sit for now. The bed is just too... Yeah, crowdsourced spaghetti detective. Leadneck is correct. Crowdsourced spaghetti detective beats out the real deal 10 times out of 10. I think we're going to let that sit for now. We're not going to start another print. The bed is just too off-center to print reliably. So I think we should bring our ergobleds... I think we should make our ergobleds happen, and then we'll call it a day. Yeah. Oh, these crimps are so much easier to use than the DuPont crimps. DuPont crimps are a friggin' nightmare. You apply like a single, just a tiny bit too much force. I was thinking of like a single Newton, but I don't actually know how much a Newton is. I don't know if that's a lot. I thought, I know they measure figs in newtons. Anyways, you apply even a tiny, tiny bit too much force, and it just mashes that thing to death. Alright. So this guy here is going to be ground. This one here is going to be signal, and this voltage. Let's just confirm that this is the case. Yep. They're labeled, and I just connected the header like the same. Wait. Nope, they're backwards. Oh, I had one job to do. I mean, I got 1 out of 3 correct. Just carefully. I'm glad I didn't stab myself in the foot when I dropped that. These are really these are really easy to disassemble. You just depress this little tab and you ruin everything because the wire pulled out, but the crimp stayed behind. Womp womp. That's fine. I have plenty more where that came from. These actually came not with the printer per se, but with the Duex kit, the Duet or the Duex. Yeah, not the best brand name in my opinion, but nobody asked. All right, so it's gonna connect like this. So this part is this one here is gonna be ground, and this one here is gonna be voltage. Okay, all right, we got ourselves a wire. So let's, so we got ourselves a wire, so let's write up some code. All right, so the right one is connected to pin 14, and the left one is connected to pin 14, the right one is connected to 15. So maybe we'll be able to remember that. I doubt it, though. Alrighty, so we're going to open this up. I'm going to set up our auxiliary camera right here, so folks can. There we go. So folks can see if it works and if it explodes. All right. So we're going to need a micro USB cable, which I've got right here. We're going to connect. All right, so let's put this over here. Let's wire up the strip. Connect this. Wait a second. I think I had it right the first time. I guess if it doesn't work, it's in backwards, right? Okay, let's connect that. Raspberry Pi is wired up. Let's plug this into my computer. Do we smell smoke? Is there supposed to be an LED or something? Let's just confirm. There should be a Raspberry Pi drive, and there is not. Alright, so maybe we plugged it in backwards. Yep, it was in backwards. Alright. Oh. Alright, so we're going to switch back over. We're going to switch back over here. So here we go. Circuit Pi. There we go. Oh, jeez. Fell over. How does this look? There we go. Alright, I don't remember... Alright, so how does this work? It runs code.py. Oh, hey, this must be one of the ones we had left over from the pimp scope. Yeah, this must have been from the pimp scope. So lucky us, we already have NeoPixel code ready to go. How delightful! So I wired this up to the port, and I'm gonna be careful not to run this over. Wired this up to the port on the right. That's the one connected to 15. Oh wait, let's call this 20 LEDs. This is GP15 NeoPixels. All right. I think this should work anyways. So let's save. And oh, there we go. Not sure if you can see it, but they're blue. NeoPixels brightness equals 1. We want maximum brightness. Let's call this 30. There we go. Oh, look at that. We got ourselves some ergobleds, ladies, gents, and cyborgs. Check it out. Let's see if we can get some rainbows going. I don't remember the rainbow code. So let's see if Adafruit. Yeah, I don't remember the code. So let's see if Adafruit has an example. Adafruit Circuit Python NeoPixel Exemplar. All right, where is it? Raspberry Pi wiring. All right, here we go. We have. All right, I'm just gonna, let's just copy the entire thing in. Alrighty. Oh, I should probably show you what's going on here. So this is just the example from Adafruit's site, and all we are going to do is we have, I think, 30 NeoPixels in here. We're going to do brightness maximum overdrive. And where do we say what pin? Pixel pin? Where's that? Pixel pin. Pixel pin equals, I guess, how do I, is this, Raspberry, Adafruit, Circuit Python, Pi Pico, NeoPixel example. There we go. No, we want the rainbow. We want the rainbows. There we go. There we go. All right, I pasted in the wrong sketch. Here we go. 30 pixels, maximum brightness, GP15. Go. I think it's working. Oh, we got an ergo printer. We got an ergo printer, folks. All right. Let's rig up another cable for the. Let's rig up the other cable for the other side, or not. I guess we could end the stream here. Yeah. Print a small. Lodge Blake Nielsen and says, print a small 3D printer. It would have to be a very small 3D printer. Anyways, yeah, that's pretty. Yeah. Let's turn our attention back. Oh, turn our attention back here, and let's build up that second cable. Oh man, yep. This is an. We're going. Everything's got a liquid cooling and RGB in it. Like sooner or later, every single object in Voidstar Lab is going to be a gaming computer. Yep, we got the ergobleds. Max, thanks a lot for another super chat. I really appreciate it. Thanks to answering my question to keyboards a few live streams ago. I don't have hand paint anymore. What did you end up using? What did you end up settling on? I'm very curious. So I know a lot of open hardware mechanical keyboards are designed more. A lot of open hardware mechanical keyboards are designed more for aesthetics than for ergonomics. They're designed for primarily, I think, 80s nostalgia, which is odd because I imagine that most of the people who are buying mechanical keyboards weren't alive in the 80s, or if they were still trying to figure out how to not poop. Gaming printer, that's right. A gaming printer. It's kind of it's kind of our thing. I don't want Voidstar Lab to get pigeonholed, but I do really like water cooling stuff, and I also like adding fancy pants lights to things. All right. Snip this. We're going to pull out the blue wire again. I don't do enough gaming. I can't look. I'm happy this project is over because now I can clear it out of here and actually play some virtual realty. So all right. So the triangle is always ground. So we're gonna go. Yep. So this goes here. Then in the middle we have our signal, and then on the end we've got power. I need to put more ergo LEDs on the printer, but there's no. Yeah, I really want to put ergo LEDs on the printer, but there's no room. There isn't a good place to put them. The logical thing to do, therefore, is to put them in a bad place. So, yeah. But yes, now we are going to have ergo LEDs. The people have spoken. And the Zack has listened. Although, between you and I, the Zack was going to do it anyways, regardless of what the people spoke. Let's see what's going on. Let's see what's going on here. Did Max... split keyboard. Excellent. Max has switched to a split keyboard. It really helps with wrist pain and shoulder pain to use a split board. I would... If you have a rough time typing, you don't have to put up with it. Like it's okay to be the weird guy at the office with a fancy, funky split keyboard. Like it's worth the money. You're probably using your keyboard, I don't know, like 8 to 12 hours per day. So it's one of those things that will if you spend a lot on it, will have a massive effect on your quality of life. What is it, like your bed, your shoes, and your chair? Ablative Kitten says, do I eat the donut? I'm surprised you haven't already. I'm surprised it survived this long. Alright, so this is going to connect like so, and as this is going to connect like this, it's going to go in here. So this time we're gonna do it right. I was right the first time. Ground, followed by signal, followed by power. Done properly. Thank you so much for the donut money, Ablative Kitten. I will use it. I can't guarantee. Maybe on donuts. They do have Krispy Kreme here. Krispy Kreme is new to Colorado-ish. Don't look at my crack. Is this one backwards too? Oh, I just didn't put an LED in that. All right, so I'm going to quickly change. All right, so here's what I'm going to do. We're going to change where it says GP14 to GP15, and yep, check that out. Now, there we go. Now the other side is lighting up. So we'll just have to edit the code to get both of them to rainbow at once. But for all intensive purposes, we now have an RGB 3D printer. Let's
Let me say we see it in its full glory. No, we need fuller glory. Fuller. Ah. It's a masterpiece.
Look at that. RGB 3D printer. Yup, there's RGB on the printer. That's how we roll here at Voidstar Lab. And with that, now that we've put RGB, now all right. So I hope that I haven't been clickbaiting you in calling this the ultimate 3D printer. It's got, yeah, I'm calling this the ultimate 3D printer. It's got 4 extruders. It's got water cooling. It's got some it's got high temperature cartridges. It's got RGB LEDs. It's got an enclosure. It's got overhead lighting. It's got a web interface, and now it's going to have a little control panel on the side as soon as I can get this thing to actually print some stuff. So, I think there should be no disputes that this is the ultimate printer. And you're going to see it in a lot of upcoming episodes, especially the next one. Not the next one, especially one in the near future, because we're going to use this thing to 3D print every other filament that we didn't manage to 3D print in the first place. So yeah, our patrons are scrolling past. Thanks to all of them. Thanks to everyone who donated. Thanks for everyone who contributed and donated super chats. I really appreciate it. It makes a huge impact. It really goes a long way. We rely very much on community support. Oh, jeez. We rely very much on community support, and means a huge difference. So we got a few patrons during the stream. I'd just like to shout them out. Let's see. Max, thanks a lot for becoming a patron. Really appreciate it. Let's see, Luis Piget, thank you very much. You are a badass. Haveboard, thanks a lot for becoming a patron. And nope, that's. Some of these are for the other ones are for Patreons that I am subscribed to. So yeah, thanks to everyone for showing up and for taking part in our building the ultimate printer. It's been real. We've gone through a lot of baloney, gone through a lot of crap in order to get here, but I think it paid off. So we're going to do some more. So after the stream is over, we're going to do some more printing. And yeah, if you want to see more of this printer, you can follow me on Twitter and Instagram. My name is Zack Freedman on all of those. If you're interested in becoming a patron yourself, it's patreon.com/Zack Freedman. And regardless, you got to go to discord.gg/Voidstar Lab. We have the friendliest community. A whole bunch of them have been here in chat. Tullen just put links in the chat. Next up is to level this bed, but I think the step before that is to have a nice little drink, because this printer is finally done and it's time for a toast. So, thanks to everyone for joining us today, and I'll see you in the future.